folks, we're going to kick off. And as we kick off, welcome to Session 3, Assessing Climate Change Vulnerability of Marine and Coastal Areas and Associated Communities. One of the first things that we would like to do is make the observation from the posters that are available, already some for viewing, but especially tonight, as well as all of the abstracts received. We note in here there has been a lot of focus in terms of specific parts of systems, specific taxa. Here we are looking at climate change vulnerability in a broader sense than just species ecosystem management. We're looking at heritage values, cultural heritage as well within this session. So just looking at a little bit of expectation management, if I can, within that. My name's Scott Heron. I am the chair of the session. I'm also the first speaker. So I've just introduced myself. Scott is an associate professor in physics at James Cook University in Australia. And he's been in Bergen for just over a week now because he was co-facilitating a workshop last week, and you might hear a little bit about that through the course of today and tomorrow. Our session runs until the afternoon tea break tomorrow. Afternoon tea, coffee, waffle, whatever you prefer. So I'll hand over to Scott. Thanks very much, Scott. And as we go into this talk, assessing climate vulnerability of coastal and marine World Heritage properties, the place to begin here is to look at the notion that climate change is a threat. It's a growing threat. And from the perspective of heritage, heritage being the things that we recognize as valuable to us collectively, societally, and sometimes that includes buildings like we see here just adjacent to us, the World Heritage property of Bergen here in Bergen, which was the focus of our vulnerability assessment last week. But we can also look just to the north from here, the West Norwegian fjords, another World Heritage property recognised and inscribed on the World Heritage list for its natural values. Here we are seeing impact on natural and cultural heritage from around the world. Despite the fact that the World Heritage System had acknowledged climate change as a threat, and it's even a part of the operational guidelines within the convention itself, there was no tool that was available to respond and help guide management response to World Heritage to climate threats from World Heritage. So my colleague John Day sit in the front, co-chair for the session, and I took this as a challenge. And we thought we need a tool that can rapidly assess climate vulnerability. We don't have time to waste. It needs to have a characteristic of being consistently applicable across all types of World Heritage properties. Those for natural reasons, those for cultural reasons, and those for both natural and cultural. And we could get philosophical about all of that piece at some point in time if we really wanted to. If you value something that's a cultural entity in and of itself, and any cultural location has a natural setting, like Bergen does with the quayside, and that connects in with that cultural heritage. Let's not wax lyrical. I just did, didn't I? Okay. We need a tool that's systematic. That's really important, but not overly complex. Because we need to be able to work this through. We have to have a proactive outcome. We can't wait for the impacts of climate change that we're already seeing to worsen, or those that we're not seeing to unveil. And as we find in all of our lives, in all of our workplaces, there are other aspects, context, reporting mechanisms, other factors to consider that we need to place this into the context of. So that was our challenge. And from that challenge, we developed what we call the CVI, Climate Vulnerability Index. It's a values-based, science-driven, community-focused process. What do we mean by values-based? We have the foundation in the property values the inherent notions that have been recognised of value. Science-driven, we use the best available climate and societal data to look at this, and community-focused. We have a participatory process. We engage members of the local community, as well as local scientists, local practitioners. For last week in Bergen here, there were discussions held with the owners of buildings, those that are in private ownership, and we had representation from the foundation, who owns about 2/3 of the buildings in the property and leads a lot of the restoration works. So it's a key thing there to connect with people, engaging with people. Stakeholder support is an important part of our storyline. So what do? We start off with a framework, and we base our framework on the Intergovernmental Panel on Climate Change's vulnerability approach from the 3rd and 4th assessment reports. Some people may not have been alive when they were published. We're up to number 6 now. And so these assessments here of exposure, sensitivity, adaptive capacity, the first 2 combine to give a measure of the potential impact, which then combines with that 3rd assessment to lead us to a vulnerability assessment. Great, good start. We want to make it World Heritage specific, and so we changed that last box to be the OUV vulnerability. Now, what's OUV? Outstanding Universal Value. This is the premise under which World Heritage is defined. So if something has values that are of appropriately outstanding nature to the universal global community, then they can be packaged up together to describe the outstanding universal value for a location. And if UNESCO puts the tick on the box, then World Heritage inscription follows. This is great. We thought this was a good thing. It's good to be able to assess the vulnerability of the values. But one of the central tenets of World Heritage is the preservation, the maintaining, the protection, the transmission of these values for current and future generations. That's that word in there. It's 3 letters long. For. Why do we do this? For the people. Any Americans in the audience, you'll probably like that phrase. So we looked in here and said, oh, sorry, I forgot this part, the modifiers. There's some modifiers that we make. We'd make some changes in the way that we add some modifiers to assess these pieces. But for the people means that we need to know what the effects on the people will be. If we have a vulnerability to the values, how might that lead to a vulnerability of community? This is not a novel concept. We've stolen these ideas from other places because we should use good things and apply them in different contexts. It's one of the things we do well in science, isn't it? So here, this follows an approach by Nadine Marshall and others that had looked at socio-ecological systems using this double framework approach, where the vulnerability of the values system becomes the exposure term for an assessment of vulnerability to the community. We put all of that in a big box and we call that the CVI. So let's just nut into this a little bit. Values-based. How do we talk about values-based? Every World Heritage property, well, almost every World Heritage property comes with a description of the values for which it is inscribed. And we, from that, derive a set of key values, a summary subset of 1,000 words into about 20 words, maybe 7 or 8 different key points. And for non-World Heritage properties, we can do the same approach, deriving them from a documented basis for the protection of that location. Partnerships with First Nations, you'll have to come back this time tomorrow and hear about those and what we do in this space when we don't have a physical document, but we have a living document that describes the values, the people whose country, land and sea country, and or sea country that might be. But that's tomorrow. Come back tomorrow this time. Okay. Whilst there are a set of values that are recognised by UNESCO as at that World Heritage High Bar gold standard, that's not to say there aren't other values that are significant, and they might be significant to the local community, they might be significant at a national level, they might even be internationally significant, just not recognised by UNESCO as World Heritage. But these are important, and these are also potentially under threat from climate change. And so within the scope of our work, we work together with our partners to say, well, how can we document these other significant property values? Down the bottom here, you'll see a picture of Skara Brae, off the north coast of mainland Scotland, the Orkney Islands, the heart of Neolithic Orkney World Heritage Property. That's one of the components of the site. And over here, an oyster catcher from the Wadden Sea, just across the bay here, down there on the north coast of Europe. To give you an example of some values, key values derived from the Statement of Outstanding Universal Value, OUV. This is the list of 9 identified key values derived for Aldabra Atoll. It's in the Seychelles, out there in the middle of the Indian Ocean. It's a marine and coastal conference, ocean. Thought it'd be a good example. Has anyone been to Aldabra? No, me neither. Haven't been to the Seychelles. This was one of our workshops that was conducted mid-pandemic. Nobody was going anywhere, but we were still able to help folks work together and assess climate vulnerability. Aldabra tortoise. I've seen an Aldabra tortoise face to face. I can say at least that much. And here you can see this variety, some habitat, some geological, some biological, and some management connected, or research management connected in there. This array of key values for that property. Another example, just from our neighbours across the way here in Scandinavia, Sweden and Finland. This is a World Heritage property that has one part on one side of the Gulf of Bothnia, Sweden, and another section on the Finnish side of the Gulf of Bothnia, the high coast Kvarken Archipelago. And we can see through here, sea level rise on the high coast Kvarken Archipelago is negative. It's great. Well, the land uplift is exceeding the rate at which sea level is changing. This is one of those places where the trampoline got pushed down and it's bouncing back heftily at this point in time. And again, so there's a connection here of landscapes, ecological processes with the geology underpinning the key values for this property. We said the CVI is values-based and science-driven. When we talk about science-driven, we look here at climate change. We summarised this list of 15 climate stressors, as we refer to them. Some people say hazards, some people say threats. We chose this word, stressors. Some of these are direct changes in variables. Some of these are integrated, second-order elements in here. But we summarised these because we wanted to give a starting point. And there was a sense that this list of 15 would likely summarise key threats to the majority of World Heritage properties. So we provide a starting point, but we also provide a space down the bottom here to say, well, what if there's something else that we want to add in? And in fact, the folks at High Coast Kvarken Archipelago said the changes in salinity in the Gulf of Bothnia are really important because of the variation of melt and the run through there and that change. So we added in an additional space here. The flexibility within the tool is such that we can do that. We build upon historical scientific data where possible. This is from Shark Bay, Western Australia, and today we're going to hear a presentation about Shark Bay, so I don't want to go too deep into this now, but we'll be hearing some more. You can see long-term changes of conditions, annual average temperature, but also counts of heatwave events, short bursts, and each of those can unveil with different impacts upon the values that are being investigated. It's good to look in the past for context, but what we're really thinking about is going towards the future. And so here, for 2 African properties, we have some of the climate projection information that we work together with partners in Zimbabwe and Zambia, Victoria Falls, Mosi Otunya, and the Salonga National Park in DR Congo as a part of our analyses there. To give an example of what we do with this list of climate stresses, we said at the start we wanted to have a rapid tool that could assess. And so to do a rapid assessment, you have to make some checks and balances. We can't do everything everywhere all the time. No? Did I get the quote wrong? Is that, no, I got it right? Okay, thanks. So what we do within our process is, through a systematic approach, identify the 3 most important key climate stresses. And for Shark Bay, Western Australia and the Wadden Sea, they each selected long-term changes in temperature as well as short-term temperature events, heat waves, as a descriptor there. But then there were different selections in terms of the storm intensity and frequency being relevant for Shark Bay, whereas sea level rise was identified as a key climate threat for the Wadden Sea. Those are 2 of the reports that have been published as a part of our work. There's more of those appearing as I click the next button. In Scotland, today is International Monuments and Sites Day. It's the ICOMOS Heritage Celebration Day on the calendar. And today, this report, with a different cover, is formally going to be released by our partners in Scotland today to celebrate International Monuments and Sites Day. Happy International Monuments and Sites Day to all of you. Orkney, we mentioned before, the Neolithic location, Neolithic archaeological site up in the far north, and the city of Edinburgh is a World Heritage property. And here, these properties both identified precipitation trend and storm intensity and frequency. Apparently it rains in Scotland. I don't know if anybody knew that. It doesn't rain in Bergen. I don't know if anybody worked that out through the course of it. It's always sunny in Bergen. But then long-term temperature change as well as sea level rise were selected for 1 each of those properties. We come through 2 cultural heritage properties in Africa, in northeastern Nigeria and coastally in Tanzania. I don't want to touch on the Tanzanian story too much because in a couple of presentations we'll hear from one of our Tanzanian partners to speak about that. But again, you can see the different selections being made through these. I've got to fill up the slide now with a few more. I can just wave my arms around and click the button a lot, and it does things like that. And you can see that there's a Manhattan Tower building up with these different aspects here. It's interesting to see the Manhattan Tower, but the thing that I really see in this is that every location has a context-specific threat. And that's a really important thing in terms of management and being able to respond. You have to know what you're looking to respond to. The other observation I make here is that of the 15 climate stresses that we had summarised, 10 have been identified as being a threat for 1 or more of the properties that we've analysed. And that's only 13. 14 is on the bottom there. We haven't added on the colour for that. I can't work out which colour to use. Tell me which colour you think I should use. I'd be happy to receive input there. There's some that are missing. Glacier change, well, that can probably happen if we look at a glacier location. I wouldn't be surprised if that came out as a threat. There's some others in here. Not to say this is a perfect list, but hopefully that's a useful thing. One of the key messages that we have, though, from our partners is that we don't need to know that climate change is an issue. We need to know what to do about it. So what do we do about it? We work together with partners to come up with different strategies, adaptation strategies that can respond to the key climate stresses in the context of the identified key values, and then prioritise those in terms of their feasibility. And so this example from Aldabra Atoll points us in that direction. What are the tangible things we can do? Values-based, science-driven, community-focused. When we look to the community, we recognise that through the lens of the World Heritage, if there is a decline in World Heritage values, then that might have an effect on community in the economic, in the social, and the cultural connections with the property. And so we work together with partners to evaluate these. One of the key elements that we look to is to conduct a public event. So not only are we communicating with the people inside our workshops, but also providing opportunity to go beyond that. And in fact, this Wednesday night, we have a public event happening reflecting on our analysis for the Bergen World Heritage. 4 out of 5 talks are in Norwegian. I'm not giving any of those. But the other one I will be giving. So context, and there's going to be slides, so there's presentation, there's pictures. So that's what I'm going to focus on there. But here we have an in-person workshop in the Western Isles of Scotland about St Kilda in their community centre there. And here we had an online workshop for Edinburgh that had somewhere in the order of 300 to 1 million viewers, somewhere within that range. I can't remember which number. When we come through, we have an output where we look at the different key climate stresses, we work through a bunch of different assessments together with people, and we come out with traffic light elements down the bottom here for each of these assessments. This is a part of our process. We want to be transparent in the process because black boxes are hard to crack. We need to be able to share the information for the best management to occur. And it's great to have traffic lights of yellow light here, or orange, if you prefer orange light between the green and the red, whichever you like. But they're not the only outputs. Importantly, we see that through the process, we get to identify knowledge gaps, research opportunities, policy needs. We document those and we report on those so that they can become the basis for next actions through. One example that we speak to from the Sukur cultural landscape in Nigeria, it was identified that the nearest weather station was about 100 kilometres away, 60 miles. And so it wasn't necessarily providing precise information for the location. Within a month of our workshop, there'd been a response to install a weather station. Great. And to train local people to collect the data. Capacity building. Better. And so now that's underway. Some other examples of these, the Vega Archipelago, which is about here on the coast of Norway. We're down over here somewhere. The climate analysis that was used from the Norwegian Meteorological Institute, some of the other property managers in Norway said, gee, that was good, can we have one of those? Which then led to a funded effort to supply all other Norwegian properties with their climate history and projections relevant to their properties. Fantastic. Some of these are just questions. We need a better survey of the marine areas for physical and biological data in St Kilda. That was a clear observation that came out there. Challenges, variations, insights. Timing, Goldilocks. Not too long, not too short, just right. That's what we aim for. Is it a constant process, a consistent process, or a customized process? And the answer is yes. There are aspects that are defined and there are aspects that are flexible to be able to make it relevant to the property needs. We had to undertake a pandemic response because no longer could people travel the world, so we moved a lot of our efforts into Zoom-based analyses, including that public event that we saw just earlier. And complex communities has been another challenge that we've encountered. High Coast Kvarken Archipelago, one community at the High Coast in Sweden, one community in the Kvarken Archipelago in Finland. They're not the same people. They're not the same places. They don't have the same responses. So that measure of complexity helped us to guide in and create more processes. We also have to develop, we have also developed in response to need different approaches, that some of which only look at that first values vulnerability assessment, we call it a snapshot, all the way through to our full workshop and a silver model in between. We're going to see this slide in another couple of talks' time and a reflection and application of that. It's important to know what you do and to know what you don't do. So here we have the things that the CVI does achieve. A systematic assessment evaluates a baseline condition and recent trend, focuses on key values, identifies the unknowns. They become known unknowns. And it raises awareness through some of the public outreach. But we are also realistic. We know that we don't undertake a deep dive analysis with all climate stresses, evaluating the elements of the property individually. It's a higher altitude approach. We don't pursue the new research areas, and we don't pretend to say that we provide all the solutions. But for a lot of the communities, it's a really good starting point. To give you an idea of some of our different outcomes, this is chronologically through time. The green ones are natural World Heritage properties, the orange ones are cultural, and the purple one that's about to appear is recognised for both natural and cultural values. The one in the box is a current nomination from the UK. So we worked with a nomination that's not yet a World Heritage property, and we've added the one over here on the left on Friday night. That was when we finished our workshop there. 1.2 hectares, 3.6 million hectares. There's a lot of diversity in World Heritage. Marine and Coastal Conference, right? Let's focus in on those pieces. What have been the key climate stresses for some of our different applications in tropical and temperate zones? How many times have those climate stresses? What have been the traffic light outcomes here? The thing that really captures my attention on this slide is diversity. I come back to that point. Not everywhere is the same when it comes to climate change and the threats and the impacts that it brings. And that's ultimately why. Why do you need this? Because you need to understand how to respond. Now, do you need this, the CVI? No, it's broader than that statement. Do you need this, an effective climate vulnerability assessment? And that's why we're in the room today, because we want to talk about climate vulnerability assessments, assessing climate vulnerability. As a part of our commitment to our community of practice, we produce every 4 months a one-page electronic newsletter. It arrives in an inbox. There's no other spam. If you would be interested in receiving that, then you can see we've had 12 of these across the last 4 years of producing them. The most recent one just now. And if you look down here, see it? See it? Just there. We gave a shout out that we were coming to Echo, and we're excited to be here. That's our webpage. It has all of the history, so you can track through the history if you are so interested. And the story that we've been through, it's a subscription on email is the way that we approach that. I don't have a whole lot of time for questions or comments, except that because there's a couple more slides in my presentation to come, which are about the session rather than about this talk. But just to briefly pause and say, is there one or two perhaps questions that we might take over the course here? We've learned as a conference that we want to take the microphone and bring it to you rather than bring you to the microphone. So if you do have a question, John's going to bring that to you, and we have a punter. Maybe it'll be faster if you came to the microphone. No, I'm just kidding.
Was it you? No, sorry.
Yes. Ooh, thank you. Especially for the natural properties, I was intrigued that you don't have any biological stressors. Some of them will be fairly well correlated with the physical ones that you have,
yeah.
But some of them might be synergistic, like invasive species, like the rats or something, are going to drive something that wouldn't be predicted just by those physical things. How have you approached that? Obviously, you can complicate things, but that's a comment would be great.
That's a fantastic question. Inside the process, we recognise that there are some climate-related stresses and there are some non-climate-related stresses. And through the sensitivity assessment, we incorporate those as compounding factors. How might climate change alter the likelihood or work synergistically, antagonistically, all of the above, with a climate stressor? So that's the focus that we put in. And our target, our box, is to look at climate vulnerability. So it has to connect across to climate, but that's the way in which we do that.
One more and then we
Yeah.
move on.
Thanks so much. That was a wonderful talk, and I very much appreciate your sense of humor. So,
Not everybody does, but thank you.
all right, so you've developed a process to evaluate and organize your threats. Could you talk a little bit about, once you've done that step, how you use that information to prioritize actions?
Great. It's a great question. We don't. But because we work with local partners, they do. And I don't want to steal the thunder from the talks that are coming that are related to CVI in this session. Not every talk is. I want to put that out there straight away. This is broader than just this one tool, but there are going to be examples of that spoken. And if you're not here for those talks, then come and have lunch and we'll talk about them afterwards. It's a great question. Thank you. That's the session header again, and as I wrap up this first one, and as Dan makes his way up to come and have to present his, when we pitched this, our focus was about assessing climate vulnerability. But many of the abstracts we received were about impacts from climate change. And we recognised that there was no place in this conference to speak to just that piece. So we went back to the ECWO organisers who, gratefully for us, said, yes, we can incorporate that, we can both and broaden the session. So today we're hearing, but the session title didn't change, but we're hearing more of those stories coming through. One of the things that we did do was always envisage that this session would have some discussion times, because it's always good to have presenters going one way and a couple of questions coming back, but it's better if there's some opportunities for integrating within the room. So in every one of our time slots we have, except for this one, this first bracket, we don't have a discussion time, but this afternoon in both sessions, tomorrow in both sessions, we have a dedicated discussion time. So please come with your flavour of input. Don't forget that in addition to today's and tomorrow's oral presentations, there are poster presentations, and we had a workshop on Sunday past that also looked into this topic. If you weren't there, you missed out. But we might have a reflection on that. I'm going to come back to this in a later point because it's time to hand over. I'd like to welcome, if we can move to the next talk, please. Thank you. I'd like to invite Mercy to come up and join us. I make the observation, it's the classic quote from George Box, no models are right, but some are useful. And I'm paraphrasing there, but I think that's great. Folks, we welcome Mercy Mbogelah to come to the stage, and I will hand it over to you, Mercy. Thank you.
Okay, thank you. Good morning, everyone. I'm Mercy Mbogelah, a site manager for the World Heritage Site of Tanzania. It's called the Ruins of Kilwa Kisiwani and the Ruins of Sonagnon World Heritage Site. I'm going to present to you our presentation called Preserving One of the Most Beautiful Cities of the World, results from the Climate Vulnerability Assessment, CVI, of the Ruins of Kilwa Kisiwani and the Ruins of Sonagnon World Heritage Site. The project is values-based climate change. The risky assessment piloting the climate vulnerability index for the cultural heritage in Africa, the CVI project. We had a collaboration between 4 investigators, and 11 other organizations on 4 continents. As the 2 elements involved, which are the capacity building, where some of the experts from the trainees from the African countries will get trained through the CVI workshop. The workshop at 2 areas, in Tanzania, where I'm come from, but also in Nigeria, in Sokol landscape. In my presentation, we'll go to see the background to the inscription, climate and other impact World Heritage List inscription and removal, and the reason of being chosen, why we choose CVI in my country or in Nigeria, so-called. So in the background, we're able to see the history of my site. My site is an archaeological and historical site. It dates back from almost 1,000 years back. So in the site, we have a lot of historical building, like the Great Mosque, which dates back from 11th century, and is one of the oldest mosque, historical mosque in the coast of East Africa. We have there in sight. But also in the background, I will show you the videos so you can manage to see what we have in the site and how the site is impacted with the climate change. So let's go. While you are sitting.
Tanzania, moja miji ya kifahari na kupendeza kuliko mingine ulimwenguni. 1332 imniba tutathibitisha Kilwa na dola yake liyosimamia na kutawala biashara zake kusini mwa Somalia mpaka Sofala hata Uchina mpaka Arabuni.
Thank you. I think it's enough. You can find more on my YouTube channel. You can just Google Miss Mbogelah. Okay, because the time is not enough. So the key values from the songs you see the inscription of the site into World Heritage Site since 1981. But in 2004, it was inscribed as in a danger list because of some many issues, including the decay in some of the archaeological monument over there because of the climate changes. But conservation efforts have been undertaken, and 2014 the site was removed from the danger list, so we are removing now. So the key values from the statement of outstanding universal value of the ruins of Kilwa Kisiwani, you can find almost 7, although there are more. With CVI, we explore more values. So we have the ruins of Kilwa Kisiwani, I have said. You can see there is a Portugal fort. It dates back from 1505. It was constructed by Portuguese. But also the Great Mosque I've said to you is this one. I don't know, black? White, is this one. This is oldest and standing Great Mosque in the coast of East Africa. And this here you can see how the site is impacted with the climate changes. This is among of the building which is very close to the ocean, as you can see. So we can see later the climate stressors in the site, although I know you already understand what the threat on the site. So also the Swahili trading history, Kilwa, Kisiwani, and Sonagnon, it marked that is an ancient trading center in the coast of East Africa, but also diverse culture history, which until now we're preserving the culture because the local community, they are living within the site. But also Great Mosque, as I said, other key building, we have many more because in history, Kilwa Kisiwani is almost 32 square kilometers in size. In history, it tells that the whole island was constructed at the past. But also we have the archaeological remains and the ruins of Sonagnon. This is a sister's island, it's close to Kilwa Kisiwani. The CVI, the COVID connectivity and inclusive. During our project, we faced COVID challenges. So we did manage to meet in person. So, for instance, the workshop we did through online meeting. So, we had pre-workshop webinars exploring key parts of the process, climate science, heritage, and socio-economic value mapping. So, we had a workshop in Dar es Salaam. So, with the other people, including the local communities. We involve the local community in our project. In all Iceland, we have we call the Ruins Committee from within the local community. So we share with them the ideas, and we have their decision and, on how to discuss about the adaptation measures on the site through the challenge we have. Here you can see the value mapping exercise, examples of significant property values. There is biological diversity. The site is rich in terrestrial natural assets, which are important to the community, but also aesthetic values of phenomenon, economic values also. Most of the people in the site are the fishermen, so they had an opportunity of fishing. But also recreation values, historic or cultural values. We have a lot of archaeological building on site. Also learning all scientific values, traditional crafts and local knowledge. The local community within the site, they know how to make some of their own things, like the local boat. They know how to make a local boat with local materials. They use this local boat for fishing and for transport. The climate modeling assessing potentials. Here you can see the climate stressors in site with the associated key values. I'll send you Olivier. Most of the climate stressors in site is intensive precipitation events. You can see here almost all key values are impacted with this, but also sea level rise. You saw the building close to the monument, which impacted with sea level rise, but also coastal erosion. Some of the monuments as well, which are located along the coastal areas, are much impacted with the climate change. Coastal erosion is a big challenge. The overall site vulnerability, you can see here, the key climate stressors with the as we assessed if the value of exposure, sensitivity, and adaptive capacity contribute to derived outcomes for potential impacts of OUV. Here you can see some of the adaptation measures we took because of the impact of climate change on the monument. This is the stairs to go inside the Husuni Kubwa Palace. Husuni Kubwa Palace is a big palace with more than 1,000 rooms and is impacted with the climate change. So some of the walls are eroded because of the impact of sea level rise. So here with the local community, in everything we involve with the local community. And with UNESCO, we've been able to train them how to do rehabilitation with the same materials. So everything, rehabilitation or conservation issues, they are doing. So here is, we're mixing lime mortar. Our building was constructed with lime mortar, coral stone, and mangrove trees. This is among of the local materials. But also the lesson learned and the future steps. The importance of MARAB, flexibility and site-specific set of tools, the importance of replicability and aligning vulnerability assessment to management plans, hearing from a wide range of stakeholders, but also development opportunities, how to incorporate a plurality of values, thinking about both direct and indirect hazards. The resource, the all talk, you can go through this website. You can able to see what we did with the CVI team. Here is a book called The Application of the Climate Vulnerability Index for the Ruins of Kilwa, Kiswani, and Sonagnon. And to make the public awareness to the local community so that they can manage to understand what we did, we translated this book from Swahili language. Swahili language is my local language, national language. Everyone in Tanzania speaks Swahili language. So we translate into Swahili language. Everyone in Tanzania can manage to understand it. So you can find all this through this website. Acknowledgement, without forgetting, my travel supporters, Intergovernmental Oceanic Commission, MDPI, Heritage Juno, and the CVI. Thank you for supporting me. Thank you.
Thank you, Mercy. We have a very brief moment for one question, if there is one question from the audience. Then I think we're going to proceed on. Yeah. So thank you very much. For anyone who came hoping to see a talk about fishing villages in Tamil Nadu from India, we had a cancellation of the talk that was scheduled, so I apologise for that. However, good news, Susan Bain from St Kilda is not going to be presenting, but is about to see up on the screen a presentation on her behalf. Susan had originally planned to be here at ECWO and was unable to come, so instead you get to hear me pretending to be Susan. And so I'm going to apologise for that right now. We have a wee talk on assessing the Climate Vulnerability Index for St Kilda. It's a wee group of islands in the North Atlantic. It is actually a wee group of islands in the North Atlantic, and if we look at the World Heritage Properties of Scotland, there are 6 in number, a 7th to come, and working with the key management agency in Scotland, Historic Environment Scotland, we've undertaken 4 CVI analyses at 4 of the 6 properties, the other 2 still in planning, plus in this area of the country, the nomination that is that is currently in assessment. St Kilda is over here on the western side, way off the world, and is the westernmost point of the UK, so I'm told. St Kilda was inscribed in 1986 for natural values, and it was then extended in 2004, and then further inscribed for cultural values, becoming a mixed heritage property in 2005. Originally, the inscription was about the landscape and a lot of the resource, the natural resource that was available, but this location was inhabited right up until 1930 by a community of people, so we're coming up on the 100th anniversary of when they elected to leave from the St Kilda archipelago. Scottish climate. The UK has a temperate maritime climate, cool, mild climate, changeable weather. Apparently rain happens in Scotland, and climate change means that winters will be getting warmer and wetter, and summers will be getting hotter and drier, and this is a key thing, more frequent and intense weather extremes. That's a general statement for Scotland. And again, here's the logo for Historic Environment Scotland, the key management organisation. St Kilda is a place in the middle of the North Atlantic, so does it really have anything to worry about? And the answer that our science partners and our management partners came together with was a whole bunch of yeses. And what are the different factors now in the future and the relationships there. When we talk about the key values from the Statement of OUV for St Kilda, these 6 were identified. Again, landscape and the resource there coming through, but then also the cultural elements down here, this relic cultural landscape. To give you an idea of what it looks like an amazing mass of seabirds. And if you know anything about photographs like this, you can't see birds in photographs like this because they just look like the bottom of clouds in the sky. An immense number of seabirds and an incredibly important place in terms of a stopover on the flyways in the North Atlantic. Some puffins because they're cute. Some undersea resources apparent as well, and then, as mentioned, the cultural heritage resource in there. One of the key elements of the CVI process is to do a baseline assessment. If we ask the question of what's the condition of different values now compared with the time of inscription and what has been the trajectory direction on those, as we look through, the key take home for the St Kilda folks was the seabirds were the identified value that was at greatest risk, and the condition was at the lowest level, a critical condition, just looking from yesterday up to today. And that's not to speak of what's happening in the future. This was just a moment, a baseline to set in there. Through the analysis for these different values, and somebody talked about these key climate stressor options previously. I can't remember who that was, but somebody mentioned that. The group identified these as the 3 most important climate stresses to evaluate within the CVI process. A scenario being implemented here was to look at this measure of temperature trend as we head towards 2050. This, in terms of a warming change, this provided a scenario to be thinking forwards and impacts for St Kilda, the storm effects that would come, and the changing currents. Changing currents was one of the places where it was also identified as a research opportunity or a knowledge gap, to say we need to understand how the currents are changing in the North Atlantic better than we do today to be able to effectively speak to vulnerability in the future. Yet it was still selected by the group as being an important climate stressor to include in the analysis. You can see that some of these are quantitative, others are qualitative in their terminologies, but informed by the best available information. Sometimes we don't know everything yet, but that doesn't mean put it on the shelf, come back to it when we do. We still need to proceed forwards. Thanks, Dan, for earlier making that point as well. So if we look at the different assessments of vulnerability on a traffic light scale, the vulnerability to temperature change and storms was assessed in the middle or moderate category, and the changing currents was identified as a red light trajectory. Those combined together to give an overall moderate assessment of climate vulnerability for the outstanding universal value. We assessed a group of different economic sectors, and these were discussed within the workshop, and the assessments for all of those pieces were built together, as well as the impacts on the social connections with the property and the cultural identity associated with the property, to take that moderate vulnerability of the values and to consider the effects on the economic, social and cultural for which a low vulnerability was assessed. There's one key aspect of this that I'd like to draw upon. On St Kilda, there are 3 managers who live and some Defence Agency staff. The 3 managers are there for only 6 months of the year. The Defence staff are there 365, so year round. But the low vulnerability of the community there was apparent because there's hardly anyone. However, the analysis extended and included the Western Isles of Scotland, because those are the places where the people from St Kilda moved to, and there are still family members of original St Kildans who are living, descendants of St Kilda, to say, in the Western Isles, and the community was extended to include those as a part of the reference point. Actions and ideas. We heard earlier, what do you do with this? And our answer was, we don't. But we work together with the partners to look at what the options and the possibilities are going forward. Some of these are research needs, some of these are connections to community, some of these are about management activities, and all of this is about adaptation to future change. And that's the end of a St Kilda talk that I'm not going to try and break back into a brogue for, but I'd be happy to take any questions. Part of that has been very quick because, number one, we started writing at about 10 o'clock last night when we found out that there was going to be a gap today. And number two, because I'm not the best person to answer, to speak to this. The property manager, Susan, who was unable to come, would be the best person. However, be more than happy to take any questions if there are any questions. Please. Okay, yeah, I'll go.
Thanks. I have a big picture question, and maybe you won't like it. But I read a book called Green Colonialism, where the author argues that the UNESCO natural sites classification in Africa was based on this colonial idea that Africa was pristine and without humans, and led to forced migrations of people. And so I was wondering how this fact could be integrated into the community aspect of vulnerability, and if you've thought about that.
Sure. So in terms of forced migration, the evacuation of St Kilda was not a forced migration. That was the local community saying that we cannot sustain livelihoods here, we cannot sustain life, and we want to be evacuated. So that was an elected point there. I'm not familiar with the book. So that sounds interesting, though. I'll have to catch the name of it from you again later. And the question of, is World Heritage perfect or imperfect, is beyond the question of, is it vulnerable to climate change? I can actually speak from my personal perspective that I think that World Heritage is imperfect. But I think all of our structures that we place onto things are probably imperfect as well. Kind of fits in the same notion as models. All models are wrong, some are useful. I think that World Heritage as a concept is useful. And so do I think it's perfect? No. The division of natural from cultural, I think, is the starting point of imperfection. does it make sense to value some part of nature, which is the cultural entity? Does it make sense to recognise a cultural value which is housed within its natural environment? So I think that's a philosophical question that deserves aquavit, if I can put it into that context there. But thanks for your question. I think one of the other things that was useful for a St Kilda talk is that it allowed us to get a little bit closer back on time. And so I would like to welcome up Nalini, who will be providing the next presentation. And I can put that down there and get out of the way. Socioeconomic vulnerability of coastal communities in Mexico to climate change. Thank you, Hem.
You hear me? So coastal communities in Mexico are all vulnerable to climate change. How much will depend on a variety of factors, and these can be socioeconomic or where they're located in relation to different environmental factors. And those coastal communities go from commercial ports to tourist resorts to small communities that are wholly dependent on fisheries. Mexico is a federalized country, which means that a lot of the decision-making is centralized. There's a national climate law, and that law dictates that managers take into account climate change in their decision-making. But that means that often this decision-making starts at a national level. For this reason, the National Institute of Fisheries approached our research team asking us to develop vulnerability assessment focused on fisheries and aquaculture so that they could use it to prioritize funding streams and management actions. And we ended up developing two different assessments, one just for fisheries and one for aquaculture, but I'm just gonna talk about the fisheries one today. Our results are already published. There's a report that the government has made available, and at the same time, we have made all of our data available. So I just want to highlight that this is part of a larger multi-stage project. We started with a rapid assessment starting in 2020. When the government saw that, they said, well, we need more details. We need more information for decision making. So we did a second stage, which is what I'm going to present now. When they saw those results, they said, oh, we want more. So we're right now in the third stage. And I'll talk a little bit about the end, about how the results that I'm presenting contributed to figuring out what is still needed and what that next stage is. So what we found is that there is high variability at the local level in vulnerability, and that variation in vulnerability is mainly either because of sensitivity or exposure. There's communities that are very sensitive to the impacts of climate change, and then there's communities that have a high exposure. And I'm going to tell you how we got there and how we're using those results. I just want to point out that this is just part of the research. We also looked at changes in distribution of commercial species, how that's going to change in the future, how the distribution of catch will also vary, but I'm not going to mention any of that during this talk. So where do we come from? So all of these coastal communities are dependent on different levels on fishing. Fishing is a really important cultural and social activity in Mexico. And this is the reason why it's so important, because the government wants to maintain the fishery livelihoods, both for economic reasons and for social reasons. But we know that climate change is going to have a variety of impacts on habitats and commercial species that are going to have consequences that are ecological and economic, as well as affect human well-being. For this reason is that we focus our vulnerability assessment, as I mentioned, on fisheries, and then did a separate one for aquaculture. And we were using this definition of socioeconomic vulnerability based on the work of Colborn and Jepson, which is the degree to which a system is susceptible and unable to cope with the adverse effects of a disturbance. And we're using the traditional definition where vulnerability is a result of exposure, sensitivity, and adaptive capacity. And we're looking to calculate each of those values for each of the coastal communities. So the first thing is that the first question we encountered is, well, what is a coastal community? So we decided to define it as those that are 30 kilometers from the coast. And the reason we chose this number is because we were trying to make sure that they had some dependence on either fishery resources or they had dependence on different coastal resources. It's not a perfect solution. There are cases where those communities that are within 30 kilometers, because of the topography, are actually on a mountain. And they actually have no exposure from the coast, but that's one of the things that we're carrying on to the next stage, where we're gonna try to narrow down those communities based on topography. And then, because we're working at the national stage, we cannot visit each of those coastal communities. We have to rely on existing data. So one of the big tasks as part of this project is we had to find what data was available and we could use. And we needed something that was standardized nationwide. So a big source of information is the national census. So we then further eliminated communities that did not have census data. And that can happen for a variety of reasons. Sometimes it's the community is too remote and the census takers cannot get there. So they'll just say, oh, you know, there's 30 people living there, but they won't actually derive all the other information. And I think that's a difference. I don't know about other countries, but in the US, the census doesn't actually ask everyone, right? It's certain census sample, but the census in Mexico is different. They actually try to visit everyone. So this is the data we used. We have the indicators for each of those axes, and those are classified in categories. And in parentheses is the number of data points or indicators that we use for each of those categories. So one of the most important ones was the dependence on fisheries and aquaculture. These are all the adaptive capacity, and finally, the exposure. And as I mentioned, we were trying to start from our rapid assessment, which had a much smaller number of indicators, and then make sure that we were considering as much available information as possible that really reflected the different axes of vulnerability. And because of that, for exposure, what we did is we varied the future ocean conditions using the SSP scenarios. So we used two different scenarios of emissions, so SSP 126 and SSP 585. And then we took all the different environmental layers that are estimated as part of those scenarios. I had mentioned that we had run species distribution models to look at changes in distribution. So we had that data came from that part of the analysis. So we looked at future chlorophyll, temperature, et cetera. So I'm going to talk to you briefly about our results. Exactly because they're national, it's actually a very extensive set of results. And one thing I want to highlight is that we wanted to make sure that these were in a format that the managers could understand and use. So we used the traffic light scheme. We broke the results in quantiles. This is the vulnerability by state. So the red ones are high vulnerability, the yellow are medium vulnerability, and the green are low vulnerability. And these are arranged geographically. So this is the Pacific Ocean and the Gulf of California. Here is starting from Central America and going north along the mainland, and then this is the Baja California Peninsula, and then this is the Gulf of Mexico also going north. So this is the low emission scenarios, and what we were trying to get here is just show a kind of a general picture of where are the different regions and the different states in terms of vulnerability. this next slide is the high emission scenarios. And I just want to draw your attention to this box. These are where we see largest change between the two scenarios. And this just is a reflection of the higher exposure of the Gulf of Mexico to environmental impacts. So the Gulf of Mexico expects to see more extreme events, more hurricanes, or they're already seeing more hurricanes. So that's something that the managers found really interesting and useful. So what does the actual data for the different axes of vulnerability look like? So this graph shows all the states in Mexico in the same order as the other figure for the three axes of vulnerability, so the adaptive capacity from 0 to 1, the sensitivity from 0 to 1 as well, such that this corner of the plot has low sensitivity and high adaptive capacity. So depending on the color of the exposure, so if it's yellow, that means that there's a low vulnerability, and then the values that are aggregating in the upper right corner have a high vulnerability. So this is nice to see what I was pointing out, that high vulnerability across different states comes from differences in whether they're really varying in their sensitivity, for example here, or whether they're varying in their exposure. So the range between yellow and orange. So for example, here. So we also created plots that look like this, where we were looking at results by municipality for the different states. And when we got to this stage, we said, well, we can make recommendations. We can say that that vulnerability really needs to be separated at the scale. And if you've ever done a vulnerability analysis, so the way they're set up is that you're normalizing the values for the different indices across your data set. So we did it at a national level. And what the government realized, the managers that we were working with, is that it was too broad of a scale for even to be useful for them. So we're redoing this assessment, and then for the next stage, where instead of obtaining a vulnerability analysis that's scaled across every state and every location in the country, it's going to be scaled at the municipality level. And that's what we agreed that was a good scale. And then the finding that the adaptation strategies are going to have to be driven by whether the vulnerability is a result of high susceptibility or increased exposure. That's another thing that we realized. So going back to our key findings, what we took to the next stage, which is what we're working on right now, is that we needed more indicators. So in order to be able to produce that resolution that the government wants at the local scale, we decided to go back to the literature, do a really deep search on all the data sets, and we actually found a lot more information than we expected that we're going to include in the next stage of indicators. And that's it. Thank you very much.
We have an opportunity to receive some questions for him, if there are any arising pieces. We also have an opportunity to break and eat some lunch, but I do want to point out that we do have a set of talks coming in the next session and again after the afternoon coffee break, so please do come back. For anyone who is a speaker registered and later for today, I'd really appreciate it if you could come up and just say good day before you head out for lunch. So if you could join me in please thanking our speakers from this morning. And we will break for lunch. Thank you. So we had two requests from the organisers. One was to take the microphone to you rather than you come to the microphone. We remembered that one at this time. The second request is lunch is that way. as well as that way, except that there's more space that way than that way. Thanks, everyone. Thanks, folks. It's always hard to know when lunch ends and sessions start again, but it's happening right now. Our first speaker, our first presentation is a pre-recorded video, and for this, the best way to communicate your feedback and any questions you have is through the app. And so presenters are encouraged to go and have a look at the app and see what the feedback is there, and particularly the online presenters to respond in that way. So anticipating no live Q&A at the end of this one, and welcome back from lunch. Thanks very much.
Good afternoon. I'm Lydia from the University of British Columbia, and I'll be talking about climate risks and adaptation in Indonesia's fisheries and coastal communities. I'm presenting on behalf of a joint research team from UBC, the University of Bern, the Indonesian Ministry of Marine Affairs and Fisheries, and the World Bank. And this study is funded by the David and Lucille Packard Foundation. Indonesia's oceans face multiple threats from overfishing, climate change, and coastal development. Previous studies have indicated that climate risks and impacts on marine biodiversity and fisheries are significantly high in the Indo-Pacific region. This situation is very concerning to the fisheries sector, which makes important contributions to the national economy, the country's food supply, and to jobs. So it's essential that fisheries and coastal ecosystems can continue to be productive and sustainable under future climate change. While the Indonesian government aims to improve marine and coastal resilience to projected climate impacts, and it has inserted high-level strategies on climate adaptation in several national policy documents, the research and knowledge base for fleshing out those strategies so that they can be useful for making informed decisions on the ground is still lacking. So that was the goal of the project, was to fill in those critical gaps in knowledge. In today's presentations, the objectives is to cover two of the project's main components. The first was to conduct a climate impacts and assessment and risk assessment, and the second to explore adaptation options and strategies. The climate risk assessment involves estimating biophysical and socioeconomic risks and projected impacts of climate change on marine ecosystems, fisheries, and dependent human communities in Indonesia. These projections are based on published literature, observation-based data, and computer simulation modeling outputs. The adaptation strategies are developed from participatory methods through stakeholder consultations and scenario building to identify priority climate impacts to Indonesia's oceans, fisheries, and coastal communities, and also to understand adaptive responses to those impacts. I'll now present some of the key findings from the risk assessments, and then these will be quite brief, and I'll move on to spend more time on the adaptations portion of the work. The biophysical risk assessment was carried out by UBC, the University of Bern, and the Indonesian MMAF. The biophysical study looked at changes in ocean conditions in Indonesian waters and how these changes are impacting on exploited marine species under a low and a high emissions scenario. There were 54 focal species which were chosen for their importance to Indonesia's industrial and small-scale artisanal sector, and they included shrimp, tuna, reef fish, and sardinellas, among other species. Climate impacts were quantified in 3 measures. The first was a climate risk index, which quantified species vulnerability based on given their biological characteristics and the projected changes in ocean conditions. And then the second was a projection of changes in species spatial distribution, which was based on environmental preferences. And then the third was an estimate of changes in maximum catch potential based on shifting species distribution and abundance. So I'll just be giving a brief overview of the results and not so much focusing on the modeling from this study component. The modeling shows that temperature increases are driving changes in ocean conditions, with ocean pH, oxygen levels, and salinity levels all declining. Species most impacted by these changes are demersal species in shallow waters, although some pelagic species will be affected as well. In aggregate, the maximum catch potential is expected to decrease by 20 to 30% under the high emissions scenario, which is the bottom graphs, and this is by 2050 relative to 2010. But these would get worse if we extend the time frame to the end of the century. The low climate change scenario sees declines of up to 20% in some regions and stay between 5 to 15% in most other regions by 2050. The most affected species include some of those that are critical to artisanal and industrial scale fisheries, including the Bali sardinella, torpedo scad, mackerels, and skipjack tuna. The socio-economic assessment was looking at the economic implications of climate change to fisheries, and it calculated changes in fisheries costs, revenues, and profits under different climate and fisheries management scenarios. In line with the projected reductions in maximum catch potential, the total economic returns in fisheries were projected to decrease by between 10 and 22% under the low and high emission scenarios respectively, and this was across the whole Indonesian exclusive economic zones. What I'm showing on this graph is that impacts are slightly worse for the small-scale artisanal sector on the right-hand side compared to the large-scale industrial sector. And this mostly is because species caught by the small-scale sector are more vulnerable than those that are caught by the large-scale sector. And next, I'll move on to the climate adaptation study, which was done in collaboration with senior researchers and policy officers from the Indonesian MMAF and the World Bank. The objective of this component was to identify and to co-develop locally relevant adaptation strategies for sustainable fisheries and marine and coastal ecosystems. We used a participatory approach with stakeholder consultations to gather primary data, and this was also provided the opportunity to exchange knowledge with the different participating institutions. We held 2 virtual workshops. The first workshop focused on knowledge scoping to identify the severity of climate impacts that were being experienced, vulnerable groups, and local adaptation measures. The second workshop concentrated on strategizing a plan of action by mapping adaptation options and assessing the risks and benefits. These workshops were attended by over 100 stakeholders from NGOs, fishing industry, government, and universities. We made use of scenarios depicting 2 versions of the future world under climate change, and these were used to set and guide discussions during the online workshops on climate impacts and adaptation options in Indonesia. We also created a video that was narrated in Indonesian about the scenario storyline and designed infographics that could be used as visual aids to facilitate communication during the workshops. Going into the workshop findings, the most frequently mentioned climate impact was extreme weather, which included heavy rainfalls and floods, and this was followed by coral bleaching and degradation. And rounding up the top 3 impacts was changes in fisheries. This category captured changes like a decrease in fish abundance and fish catch, and also changes in fish movement. Participants provided a broad range of adaptations to climate impacts, and the adaptation that was most commonly considered to be effective was to invest in social capital. This category included activities related to capacity building, to the transfer of skills and knowledge, and increasing education and improving social cohesion and social assistance. The second most common adaptation offered by the participants related to coastal ecosystem restoration and sustainability. And then the third set of responses had to do with governance. And here the emphasis was on increasing cooperation between institutions, mainstreaming climate agenda in development planning, creating new policies and tools for the environment, such as marine protected areas, and also engaging in multi-stakeholder policy dialogues. Using those insights, we then developed a series of adaptation strategies to address the priority climate impacts of coral bleaching, erosion and floods, and fisheries variability, and then explored the pros and cons of the different adaptation pathways in a second workshop. So here, these figures show the adaptation options, and they're just for illustration, and you don't have to try to read the print. But the point was that through facilitated discussion, stakeholders were able to identify actions that they thought would be effective adaptations and provide perspectives on what factors would make certain adaptations more suitable than others. So on this table, the response rates we obtained, it was real-time feedback during the online workshops, and we did this using live online polling. We were also able to articulate risks and benefits associated with going down certain adaptation pathways. And again, these are valuable for providing the local perspectives on potential consequences to implementing adaptation on the ground that wouldn't necessarily be apparent without engaging with diverse stakeholders. And finally, putting everything together, we proposed 3 adaptation measures for building further marine and coastal resilience. These measures were in the areas of sustainable fisheries management, coastal ecosystem protection, and strengthening coastal communities and local economies. So to wrap up, we found that Indonesia's oceans are facing multiple climate stresses and that marine species and habitats, fisheries, and dependent human communities are at high risk of being negatively affected by climate impacts. Adaptation interventions that are flexible, that protect ecosystems and empower communities may help to soften the impacts of climate change on Indonesia's oceans and human and coastal population. And these can be reached by taking an integrative and inclusive approach to adaptation planning. So thank you for your attention.
Thanks, folks, and please don't forget to make your comments or offer any questions to Lydia via the app. We'd welcome Andrea Lira to the stage for her presentation now. Thank you.
Hello, everyone. Thank you for coming. So I think I'm going to go a little bit off topic from adaptation and vulnerability and go into climate change effects into wave climates in the Mediterranean Sea. So the Mediterranean Sea is especially vulnerable to extreme coastal sea levels. This is mainly because of the population density that we have living in coastal areas, so under 5 meters above sea level. And this population is projected to increase more than 100% up until the end of the century. So, and I'm not going forward, good. So we have a lot of population that is expected to be vulnerable to storm events and coastal impacts such as erosion and flooding. Right now we have estimations of about 40% people are under moderate to high risk of coastal impacts. So there is a consensus coming from the IPCC reports that significant wave height is expected to decrease in the overall Mediterranean basin. Yet again, these projections are quite small, and the changes in winds, storms, and waves, all derived from a modeling chain, can only be as good as the models from which they are derived, right? And most of the studies come from simulations from global climate models, which we all know have a coarse resolution. So these models do not have the high resolution to resolve storm features or the very high regional dynamic that governs the Mediterranean Sea. So what we set out to do is to improve the projections of wave climate in the Mediterranean Sea by using a multi-model of wave climate projections. So first of all, I'm going to talk a little bit about this ensemble and their performance, because their performance and their bias correction leads a lot to very different results, and we're going to talk a little bit about that. So first of all, we did a multimodal ensemble. So we used 17 different models from the Eurocortex. So that is dynamically downscaled with regional climate models, different global climate models for SINs. We used the model WaveWatch 3, which is just a wave generation propagation model. So we are just dealing with waves independently. And we obtained 3-hour time series for the main integrated parameters on a 10-kilometer grid over the whole Mediterranean basin. But also, since we were seeing in recent years that the direction of waves has become an issue, there are waves that are changing directions, we also obtain a spectral condition. So that is the changes in like the definition of waves, both in period and in frequency, and in direction, in different points of the Mediterranean Sea. So first of all, a little bit about the performance. So here you have the root mean square error for winter conditions. And what we can see is that all the models strangely behave very, very similar. So that is, okay, good. We like that. And also we like the fact that their distribution, so the root mean square error, which is highly variable to outliers, so to extremes, is very similar to the distribution of the wave energy flux for Heinckas conditions, so for historical conditions. So we have higher root mean square error where we had higher waves, so that is the Western Mediterranean, the Balearic Sea. And then we had overall errors are about 1.5 meters in the rest of the basin. The lowest root mean square error is the Adriatic Sea, but don't be fooled by this. The models have it's very hard for the models to really capture the Adriatic Sea because the Adriatic is forced by very local conditions, so we need even higher resolution. Going a bit about the bias. So the bias surprises. It has a lot of spatial variability between each other, but there's something that caught us is the fact that actually in the bias, all the models that are driven with the same regional climate model show very similar distribution. Like, for example, here in the Heron 5, we see overestimations in the southern part of the basin and a little bit overestimations in the Balearic Sea. Whereas, for example, the ones driven with the RCA4 model, that is from the Swedish Meteorological Institute, they have different conditions. So for the bias, it is not the global climate simulations which are driving the distribution. It's actually the regional model, which, if you think about it, makes sense given the highly regional conditions of the Mediterranean. And yeah, we saw other models that were behaving differently. So given this, we set out to do some bias correction of our models. So we tried to use one very widespread and simple technique, which is the EQM, the empirical quantile mapping. But we were pretty interested in how wave temporal variability affects our results and affects the correction. So we used the same methodology, but we applied it using the full time series, then divided by seasons, months, and day by year. So on your left, you have just the yearly distribution of percentiles. So the darker colors are the higher percentiles, so 90, 95, 99. And then you have the seasonal distribution this is for 2 points of the Mediterranean Sea. So first of all, I want to call your attention to the fact that raw data overestimates the higher percentiles during summer. So that is that the models are overestimating summer conditions. And when we do, distribution of a correction using the full-time series, we actually obtain higher biases during summer. So we are increasing the bias during summer. This is very simple. The upper tail of the distribution is driven by the winter conditions. So when we correct summer conditions, we are actually increasing our bias. Then we see that the seasonal distribution also has the same conditions. Oh, sorry. And then day of year, as expected, it overfits our data. Okay, so we chose to keep with the monthly data, and we bias corrected all of our 17 models. So once we had that, we went into analyzing extremes and future waves. I'm going to present the results always using these periods, so mid-century and end-century with respect to Heinckas. So first, we took the indices from the expert team detection indices. So we have rough wave days defined as the number of days in which the daily significant wave height, so we are taking just the maximum, is over 2.5 and over 4, respectively. So we can see, and agreeing to to the literature that we have a decrease in both periods, so a decrease in the overall significant wave height, with the highest decreases in the parts where we had the highest waves, so that is the Western Mediterranean and Balearic Sea, up to 30%. And then in the case of the high wave seas, we have the same spatial distribution with the largest decreases, again, in the same area. And in this case, I just want to highlight that we saw that there were no changes in coastal areas. Okay, our grid is 10 kilometers, but we were getting some coastal areas. We're now working on improving our grid. But we were curious about this. We were curious why we were not getting any changes, because we didn't have that many points in the past, because it's a very relatively high wave height for the Mediterranean, but we were getting decreases for the other ones for lower wave heights. Again, we needed to analyze this seasonally. Why is the seasonal analysis so important in the Mediterranean Sea? Well, that is because it's highly tourist, right? So in summer, managers, they want to know what is happening to summer conditions, which is driving a lot of the economy of the Mediterranean Sea. So actually, in this case, we saw, that in summer conditions, we have increases of 1 to 2 days of the conditions of the high wave days, so that is over 4 meters. So in general, okay, we have that the magnitude is decreasing. We wanted to talk a little bit about the frequency. So here you have the percentage of sea states which are over the 75 percentile. And I want to highlight that we actually get some increases in the area where we have decreases in magnitude, let's say. We have a decreases in the frequency of extreme events. So what is happening? I can talk about this a lot, but I'm not because I have time. But actually, we have that the wind conditions are changing. We have extreme events that are changing in direction, and they're becoming more frequent, although the maximums are decreasing. Okay, so it is not, okay, our waves are becoming huge, but we are having longer events, which is very important for coastal management as well. Once we had our significant wave height results, we wanted to go into how waves are changing in period and direction. And as I said before, we wanted to analyze the spectra. Okay, so here you have our high-intensity spectra, and then the changes in mid-century and end of century. And I'm just going to show you a couple of results. So for the Ligurian Sea, we have that you have a predominant southwest swell system, and then you have a robust decrease for mid-century in this system, which is no longer visible in the end of century. And then you have some increases in other systems for both periods. So what we have here is, or what projections are showing us, is a clearly unimodal system that is changing into bimodal, even multimodal for future conditions. The opposite happens for the point in the Ionian Sea, in which we have a very multimodal condition for the past. And our future conditions indicate that we have a decrease in the main swell system and an increase on other conditions. Okay? So here we have a multimodal system that is likely losing the main crucial system. I do have to say that here we bias corrected just by bin, and we were analyzing just changes bin by bin, right? So every direction and frequency bin. And we thought, okay, what if the models are giving you energy shifts? We are not capturing that. Again, it all comes down to how you analyze this data. So we thought about this, and I'm currently working on this, but we are working on correcting the integrated parameter of wave energy and then reconstructing our spectra. And I just want to show you that actually for the same point that we just saw last time, we got some different results. This is just for end century, so the laser here. So we don't longer see the increase that we had here, okay? We just see this decrease, but we see that our baseline period for the 17 models, we still have some considerable biases. So we are working on how to analyze the uncertainty of these results to better understand. We are currently seeing some changes in direction in the extreme events in the Mediterranean Sea. So we think it is important for us to continue to analyze the spectra, but there are increased challenges regarding its uncertainty. So some current work and outlooks. So we are working also on bias correcting the input. So directly the surface winds from the models, coupling storm surge and relative sea level changes, and update to new information. Thank you very much.
I put it down here so I didn't have to walk over there, and then I forgot that I did that. Are there any questions for Andrea? I have a question. For someone from Genoa, you might not care so much about the Venetians, but the Adriatic Sea, how do you solve what you described as an as yet unresolved issue?
You need to increase resolution. So yeah, I mean, and I believe not only you need to increase resolution from the inputs of the atmospheric input, and there are actually a huge group from the CMCC working on developing an Earth system model, especially for the Adriatic Sea, because it has very local dynamical distributions.
It seems a pretty important task to undertake for the broader story. Yeah, okay, great. Any other? Thank you.
Thank you. I'm wondering how you think that your work can be extended to other sites. Like when I was looking at your research, I kept thinking where we work, tidal amplitude is really high, but we also have waves. So thinking a system like that, how could you apply your approach?
So I would say you need, first of all, a fully hydrodynamical model. So this is just a wave model. You need to include the currents and the tides. In the Mediterranean Sea, we have very low tides, so that's why tide is not considered as important. We have maximum 10 centimeters. You need that, and then I would say the thing with waves and all type of extreme events is that they have a lot more, let's say, inertia than the wind force in, for example, in the case of waves, right? So if you go and bias correct wind force in the atmospheric input, you're considering a lot of frequencies that are not really that interesting for waves, because waves, like, they couple, they move. So I would say I would try just by running your model and doing bias correction afterwards to your variable of choice. Bias correction is a very debatable topic, I would say. You have a lot of studies that are not using it, a lot of studies that are using it directly from the output, atmospheric, or from your model output. I do believe we have to use it in order to start to understand direct changes. And then, well, the spectra is very important. So right now, what I'm thinking on doing is just use spectra to run hydrodynamical models in local conditions. So it is very heavy, computationally heavy to do longer regions, but we can do just smaller with a high resolution.
Thank you.
Thank you, Andrea. And we transition and welcome Michelle McClure.
Thanks very much.
Thank you.
I'm going to be speaking about a more traditional species climate vulnerability assessment, and I do want to call out my co-authors here. There were 37 of them. They did not fit here. This is actually part of an overall effort by NOAA to do climate vulnerability assessments in all 6 regions that are managed by fisheries. I will not tell you when we started this particular one, but I will tell you that there was great rejoicing in February when this was finally published. So I'm going to walk through. I'm first going to give an intro to the California current large marine ecosystem and vulnerability assessments in general, which I will skim over given where we are. I'll talk a bit about our expert opinion methodology, our basic results, what came out as being particularly vulnerable. We also did a second assessment that was focused specifically on salmonids, and I'll discuss why we did that, and then I will wrap up. So the California current large marine ecosystem spans from the north end of Washington State down to the bottom of Baja California. It's an extremely productive system that is driven by upwelling. And in this system, we have a large variety of species ranging from groundfish, salmonids, sturgeon, coastal pelagic species, highly migratory species, and we conducted this assessment on this wide variety of species. They're all managed either under harvest management plans or as protected species in the region. I'm going to gloss over this, as I think that in this session we have amply covered that a species' exposure to climate change and its sensitivity to it, coupled with its ability to respond, is what leads to its overall vulnerability. So I'll talk a little bit about our own expert opinion methodology. We first compiled information about both exposure and sensitivity. We had, these were the exposure attributes that we looked at. Some of them were actually, we had quantitative measures of them. For example, pH up here, we were able to get estimates of pH 50 years out under high emission scenarios from an ensemble of climate models. Some of them, however, we didn't have quantitative estimates, so we compiled literature estimates of them, and those included things like the likely phenology of upwelling under climate change and so forth. Sensitivity, we similarly compiled information for each of the 65 species that we looked at for all of these characteristics, ranging from how specific a habitat or how generalist versus a specific habitat use, how much early life history stages dispersed, and so forth. And we did not directly assess adaptive capacity because that is implicit in many of these characteristics that we looked at for biological sensitivity. We then had a group of experts that scored each of these traits for each species, and this here is the species are in the rows, and each of the factors are across the top. And so we scored how exposed or how sensitive each species was to each of these factors. And you can see that some of them came out very high. This is actually ocean acidification. This is sea surface temperature. And then basically we compiled both the overall score for biological sensitivity or exposure using this logic rule. So what did we come up with? When we combined exposure, which is on this axis, and biological sensitivity, we ended up with over 2/3 of our species had at least moderate sensitivity, with a number of them being highly sensitive or very highly sensitive. And I do want to stress that this is a relative metric. This is not because it's expert opinion, it's not a quantitative absolute metric. And they were focused, actually, our different functional groups responded differently. So overall, for vulnerability, salmon tended to be the most highly vulnerable, with rockfishes being the next most highly vulnerable. Our coastal pelagic species and flatfishes and highly migratory species tended to be the least. We also looked at whether or not a species was likely to be able to change its distribution in response to climate change. And not surprisingly, our highly migratory species were the most likely to do that, similarly coastal pelagic species. But a number of species, those that are demersal, those that are territorial, rockfish for example, were much less likely to do so. And then the last thing that we assessed was whether our experts thought that the overall effect of climate change on these species was likely to be positive, neutral, or negative. And here, overwhelmingly, we had an estimated neutral or negative response to climate change, with only one species, arrowtooth flounder, likely to be responding in a positive way in this region. We also did, because salmon are managed on a much finer scale than the species scale that most of our harvested species are at, we also did a more fine-scaled analysis at the ESU level. So ESU is evolutionarily significant unit. It is the distinct population segment that is used under the Endangered Species Act. This was published in a paper that Lisa Crozier led. But what we found here was that there was not uniform sensitivity across the different species of salmon. In general, Chinook salmon were much more sensitive, much more vulnerable, and also our interior species, so Central Valley and interior Columbia ESUs tended to be the most vulnerable to climate change. when we looked at what drove that sensitivity or the vulnerability in general, when we looked at the exposure variables, we had both sea surface temperature and ocean acidification. So this is the average score across species, and this is when we pulled that particular factor out of the analysis, how much did the vulnerability ranking change? And so sea surface temperature and ocean acidification, which were those red and orange columns, which basically all of the species were highly exposed to, tended to drive the exposure score. On the biological side, it was much less clear cut, but some of the key things that drove it were population growth rate, which tends to be, an explicor, basically, of the overall status of a species. And also some of the things like narrow early life history requirements and overall mobility. We also looked at this question in a multivariate way, and so I'm going to kind of work backwards on this. This set of graphs here shows which factors were most important. On top are the exposure attributes, and on the bottom are the sensitivity attributes. So I'm going to walk through exposure attributes first. In this graph, they are color-coded by functional group, and so we're somewhat reassured that our functional groups tend to cluster a bit together. But on the first axis, we have temperature and sea level rise being drivers, and when we look at this together, in this graph, they're color-coded by what vulnerability they are. This tends to be associated with anadromy. So our anadromous fish are over here on this axis, and our fully marine species are here. This axis is associated with oxygenation and hypoxia. And so what we see here is our demersal fishes are down here with greater vulnerability. On the biological sensitivity axis, the vertical axis is associated with population growth rate and early life history dispersal possibilities. And on the x-axis is reproductive strategy and other factors. So things like whether there were, salmonids tended to score high here, so it tended to be things like was there habitat degradation that these species were exposed to, or was there heavy harvest, things like that. And so overall, what we found was that those other factors were in fact a key element. So degraded habitat, heavy fishing, having a very complicated reproductive strategy, or having really high and very narrow early life history requirements and an inability to disperse at that time were all associated with having relatively high vulnerability in this system. So now that we know that, we know that the vast majority of our species are likely to be at least neutral to climate change, and many of them likely to have negative effects. And we know some of the drivers. How do we actually use this? So one key use, and I'll show this in the next slide, is actually prioritizing actions. So matching those factors that drive variability to the key life stages or exposures. So when a species is exposed in a stage that we can actually do something about it, it helps us figure out what the right actions are. It can help inform when we should be taking precautionary approaches in the management of certain species. They can contribute to some of the kinds of assessments that we've seen elsewhere in this session that are more comprehensive community vulnerability assessments or the fisheries vulnerability assessments. And they can help identify priorities for including environmental parameters in stock assessments. So if there is a particular exposure variable or a particular biological sensitivity variable that's particularly important for a species, that would be a priority to make sure is included as you're evaluating management strategies for a species. And then there's also scientific uses. As we see species moving, we are likely to have to change fisheries survey design to encompass the entire population, and it can help us identify priority monitoring. And then I'm going to just wrap up with one example, and this again is from the paper that Lisa Crozier led on salmon, where we can actually, there are actually situations where the sensitivity of a particular species, or in this case an evolutionarily significant unit, is paired with exposure at a particular time. So over here, for example, at the adult stage, we have stream temperature being paired with adult sensitivity to stream temperature in this column. And so the ESUs that are in this column are ones that would benefit from habitat actions affecting stream temperature. Similarly, over here, we've got ESUs that have sensitivity at the egg or the transition phase or in the marine phase, and that is paired with sensitivity at that same time. So habitat actions targeting that specific life stage, those specific habitats will likely have the most effect and help improve vulnerability and mitigate it overall. I did think that we were going to have access to these, so these are active links, but I don't think you do. So if you're interested in any of these sites, please just let me know. You can get me through the app or in the hallway or wherever. But NOAA has an overall climate vulnerability assessment webpage that has the results both from this assessment and from the other regions that have been done. And these are links to the 2 papers that I talked about today. And with that, I'm happy to take any questions.
Any questions there for Michelle?
So the exposure scores, were they, maybe I missed this, but were they based on a projection of conditions in the future, and what was the time period of that?
Yeah, so it was a 50-year projection. And as I said, some of the variables were quantitative and were derived from global climate models, and some of them were literature-based. So upwelling is the one that I gave the example of, that we don't really know. That's not something that is included in global climate models, but we do have a sense for some of the things, the winds that will drive them and so forth. And so we conducted a literature review for those factors and provided them to our experts for inclusion in their consideration.
Thank you. I'm just wondering what you think the importance is, especially for things like salmon, where you might see different responses to climate change, even at a lower scale than the evolutionary unit, and how that plays into your results.
So for populations within the evolutionarily significant unit, if you have, for example, different conditions of low altitude versus high altitude populations, that more or less what you're asking. It certainly can affect the viability of those populations. When NOAA has addressed recovery planning for those species, they've actually gone down to the level of those populations and taken a look at the status and what would have to happen for each of those. So I think that becomes a regional planning question. So when you're looking at the ESU as a whole, what component populations do you need to restore and to what level? And then you hone in on, oh gosh, this high altitude population is not going to have as much temperature issues as this low altitude population, so let's prioritize stream vegetation restoration, for example.
Thank you.
I think we have space for one more question, Matt.
For the exposure scoring, how did you define the boundaries, particularly for the offshore species?
We did the US EEZ, so exclusive economic zone.
Okay, thanks.
Yeah, so that's a limitation in the study, in that many of these species actually go either north or south, and some go more offshore, but we did confine it to the area in which we're managing harvest.
Thanks, Michelle. So I'm just confirming with the tech team that I'm not expecting a speaker to stand up, thank you. Unfortunately, we had another non-cancellation, I guess you'd say, no show for now. But the good news is that actually enables us. because after this next 15-minute session, we had a dedicated discussion time, and people are already leaving because I've said that. That's fantastic. This is what we like to scare people out of the room so that we can have a fruitful discussion for those of us who remain, right? Isn't that how it works? No, what we're going to do now is actually pursue that. So for the next half hour, we're going to open the floor for some discussion pieces. And I think I want to be controversial. So if you want to, I want to try and, say something that people are going to argue against, because then you'll start talking. And so that's a part of what I see as my role here, is to get you talking and get me listening. But before I do that, I just want to open up to ask if you have any discussion questions. Is there something that you've seen so far in S3 that is challenging you or that's making you want to ask a particular question? So just rolling, not a presenter specific, although you can direct your question at a presenter if you would desire, but is there a question where you look and say, from what I've seen, here's an overarching comment? I'm throwing that open. Thank you.
I guess this comes from seeing the wave height presentation and then these other things maybe with temperature. When you try to do a vulnerability assessment, how would you deal with interactions where, sensitivity or maybe actually a response to one of those stressors may make you more vulnerable to the other, or other ways that they might interact, sort of generally how you guys are thinking about it in your systems?
Interactions, I love it. I love it, interactions. Any comments from anyone? I actually had a question about this with one of our previous presenters, Nalini, who presented a vulnerability assessment for fisheries and for aquaculture. And it seems like the vulnerability of one could serve the benefit of the other. Maybe I'm just saying something controversial to make people go, ooh, I don't know if I like that. Thoughts, interactions. What do we do with interactions?
I can talk about how we address that. So in the assessment for fisheries, we included where there was aquaculture installation at like a given city, but we didn't include more detail than that. Like we left that for the aquaculture. And that was it just was born of the specific questions and how they wanted, the fisheries agency wanted to be able to distinguish between both. But I agree with you that there is interaction with both, and you have to think about that.
I guess I think from what I know about aquaculture, it actually benefits from warming, like it grows faster, whereas some of the wild stocks are not. So I guess not only a spatial interaction, but actually like the directionality of the effect is opposite, which I think incentives are different for sure. So yeah, I think really, I like your provocative question.
I'll take a thanks for that. But in incentives, are we incentivizing aquaculture as a global community? That's an interesting perspective.
No, it's going back to how do we, like, if we have something that increases another thing, without thinking on how it can be modeled, because it's very hard and computationally cost, I would deal with it something as the feedbacks, as the climate feedbacks that are within global climate models, which for them took them many, many years to actually be able to model them. But I work in waves, so I would think around like coastal erosion. So usually the beaches, they restore themselves during summer. If you can manage to do a whole system in which the response of the beach is also taken into account and how the waves are changing when they arrive to the coast, that would be great. Yet again, that is very hard. But I would ideally, I see it as something as feedbacks.
Feedbacks, positive feedbacks, negative feedbacks that produce positive feedbacks that produce negative impacts. Like we heard about from one of our plenaries, ice melting in the Arctic, and the positive feedback by its definition, which is a negative, coming through there. Obvious example, I think. Any other comments and thoughts there? before we might move on elsewhere.
It was actually a slightly different question that I wondered about during all the presentations where people engage the community, which I think is really important and useful. But it strikes me that there is some level of grabbing the interested, and those who happen to read the newspaper that day or whatever it was that brought people to that. And I wonder how those of you who are doing that compensate and avoid having a self-selected group that might have a biased perspective compared to the community as a whole.
Great question. Thoughts, responses? Even if you don't have a personal experience in that space, you may have a reflection on that. So I just want to open it up to say that everyone has an answer and is able to respond.
In my experience working in the Great Barrier Reef, when we were doing a major policy change, we were hearing the noisy minority, which is what you were talking about. How do we get to the silent majority? Because we were trying to influence decision makers to make a final decision, and recognising this was complex, we threw at them the same technique they use, which was polling, telephone polling. So we were actually randomly choosing people far outside the catchment, far outside the area of interest, getting that feedback, which really worked with the politicians. So they were hearing not just the noisy minority that you were talking about, they were hearing really the overall view of people about this issue. It was complex to design the questions that would work on a telephone survey, but we did, and the politicians really used that. So that's one technique.
I think if I can add on to that, another strategy is to take the oxygen away from mob mentality. Which is to not have a town hall where everybody speaks to everybody, but you divide and conquer, so to speak. You take that capacity of a momentum growing from a small voice becoming a louder voice by saying, no, everybody just have the side conversation, which is one example of a telephone call, if I can point to that.
Yeah, in the experience of our organization developing spatial planning process to establish fishery refuge. What we did is they created like a community group with leaders, and they made sure that the leaders met with small groups of the community and that transmitted their input up that way. So you never had a meeting where like everyone in the community was there, except like maybe at the very beginning, because there were like these stages where people were divided in groups just to make it easier and make sure that everyone was heard.
I guess on that same sort of theme, how have you guys dealt with like stakeholder fatigue? Like, because everyone isn't, all the scientists are really interested in fisheries and climate change, and so we keep talking to the same people, and especially if you don't do what the Western Australia, where you give the information back, they're like, what do I keep talking to you? Nothing happens, or whatever. So how do you guys think about that in your systems as well?
Anyone? Thoughts, comments? I think you've answered one part of the question there. My perspective is to say that if you're not giving feedback, if you're not returning investment, then it's pretty hard to maintain. The work that we've done with First Nations people in Australia, and I don't want to steal the thunder of my colleague who's presenting or has this a part of his presentation tomorrow, but one of the key aspects there is also to recognise a gatekeeper who's protecting the interests of the community and to work in partnership with them so that you can have a candid conversation about where's the sweet spot, how much is too much, and I think that's a valuable piece of the investment pie there as well.
I think it's really hard, and I don't think there's necessarily a good solution. So for that spatial planning project, the problem was, like, we finished it, we had like all the Fisher's Refuge, we had all the buy-in from the community, and then the federal, the presidential elections happened, and everyone changed all the way down to the local fisheries office. So then we had to start again, like informing each of those people about the process. And by then the community was like we're tired of this, like we want nothing to do with it because they didn't want to have to go through it again.
I was just going to say that I had the same problem of fatigue, and I don't really have the solution. But, you know, if you're in the position of being the first to interview a certain group of people, we were having this conversation at lunch between a bunch of social scientists, that one of the main, you know, things that would stop people from wanting to interview is when they've been interviewed before, like you said, and never heard anything back about, you know, they gave up their time and then never heard anything of it. So that's probably a protocol that we can follow. But I don't have the solution for when there's already fatigue, unfortunately.
I think being very transparent about the stakeholder group and who's been engaged is also helpful, because sometimes we would be engaging a stakeholder and they would see who else we're engaging and they would say, okay, if this group's involved, we know that our views will probably be expressed through that group. So we may not need to be involved if our views are also being expressed elsewhere. But they only know that if you're transparent about who you're already talking with.
Sharing the load, sharing the load.
I think another aspect of this, though, is not raising false expectations with stakeholders and rights holders. There's sometimes when we consult people, an expectation everything they say will be taken on board and it'll, you know, appear in the answer. And I think there's this false expectation sometimes raised. So you've got to be upfront and say there isn't such a thing as a win-win in a complex situation like this. Often it's going to be a lose-lose-lose. But you also have to stress, unless you get involved, we won't know what you're thinking. And we found that with a lot of the fishermen said, we're not going to talk to you guys. We said, well, if you don't talk to us, we won't know what you're thinking, so please do. And we convinced them, but we also stress this isn't going to be a win-win and everyone's going to get exactly what they want.
I love what you just said. I think that's really important. Also, there's just so many beautiful things that are being shared here today. It's absolutely wonderful. I'm based in Japan, do a lot of work in Micronesia and the Pacific Island states, and I think that ensuring that there's an informal place initially, and that I think there's a big voice for co-designing, co-ownership, and if you can, it takes a lot of time and sometimes energy that you're not sure that you have, but you should find it somewhere and pull it out, because if you bring in all the different voices, the different age groups, the different, you know, from your fisher groups to your industry groups to your government to your academics, your NGOs, NPOs, I think if you reach out properly and bring them all in, it is so rewarding in the end. And I think that, I don't know, it just depends on the culture, the country, all of that goes without saying. But I think that the informal side, where you are really transparent, where you're honest that it might be lose, really lose for a lot, but come on board anyways, because even if we lose now, maybe if we pay it forward, the wins at the next place. And I think that doesn't always respond to the fatigue side, but it's also, I think, mapping out what's been done before. Do a lot of work with ODA projects as well, and that's also, it's not just on the research side, but where there's so much fatigue and people say, look, we were asked the same questions like 6 months ago, so go talk to those people. So it's also being able to access those contacts to pull in things so that you don't enforce that fatigue where you don't have to.
I think it's also a symptom of life. I used to know the name of my bank teller. So I'd walk in and I'd say, hi Cheryl, how are you today? And that was the relationship that we had. And that took time to develop, and there was a connection there. Now I don't even have a bank branch. So the only thing I can do is ring up an anonymous person on the phone and talk to a machine. And so I think transactionally in what we do, there's also a notion of that. If we're engaging as if it's an ATM, then we should expect ATM-worthy interactions, which is, do you want a receipt? And as opposed to if we're having a transaction which is relational, then we can get a very much a different aspect. We might understand. Somebody already asked me those questions. Fantastic. Now you get to decide as a practitioner, scientist, manager, whatever, do I want to engage another collaborator, or do I want to let go of that part of my analysis because they're not going to answer my questions because they're the same as those questions? We still have options in front of us. Yeah, there we go.
Building on that also, I have recently been getting more involved with local communities and Indigenous peoples, and a lot of what I'm hearing is that, so you, they'll get interviewed, and then, they just want to be involved. If there's an opportunity for them to see what you're doing, even if you don't have results, they just want to see, what you're doing. They don't know, not all of them necessarily know if they're in their small community. It's kind of nice to pull them out and be like, this is what we're doing, how we're doing it. And this is a possibility if you want to do it on your own and learn. That's something that they are all really keen on. And it takes a lot of time in building that. And even research takes years. You never see results. And same with relationships. It takes so long. But yeah, even just providing a consistent opportunity where eventually maybe they'll pick up on this, and young people, they want opportunities. If there's field research, they're jumping on it and providing funding. That's what they struggle to even do transport. So it's oh yeah, if it's free to get into the city, if it's free to come with you out and do some field sampling, it's super cool. And it's really rewarding also.
Thank you.
I don't know too much about it, but doesn't it come down to how you involve people? You talk about give people, generally I think giving people responsibilities makes people become less fatigued. Even if they're fatigued about something, give them a responsibility. Maybe it will change. Make them, whoever you are teaching something, make them the next person to teach the next person the next thing in their local community, so that they feel like they actually own this, like you said, co-owning. Yeah.
So thoughts on creating those opportunities? How do we create those opportunities, apart from walking in and knocking on the door? Or are there other ways in which those opportunities get created for us? We heard earlier today from Jenny Shaw in Shark Bay, a 2011 heatwave event that killed off close to 30% of the seagrass species that are foundational to the existence of Shark Bay. Yes, I do know a little bit about this. And so that element was a catalyst event. Are there other ways that we can think about catalyzing action, engaging with communities, taking those opportunities of momentum that are, read this word carefully, gifted to us by the circumstances beyond our control? But how do we best take advantage of those? What are the key aspects of, if there was a climate impact unveiled before our very eyes, what could we do to respond? What are some pieces? Nothing. We can take a deep breath and sit in silence as the chaos of climate change descends upon us.
I think part of it is actually before the event happens. So knowing that there may be an event that happens in the future, there likely will be an event that happens in the future, building up an organizational name and recognition that you're a trustworthy organization, that you will be transparent and honest, and all of those things that help build trust, so that when the time comes, you're already in a position that you can serve in that role.
So how do we do that? Oh, now we've got some hands coming.
Well, I guess what I'm trying to do in one of my projects is go to meetings that are already happening. So there's a shellfish advisory board, and previously I was oh, I think they must care about this. And we got feedback from a pre-proposal of did you actually ask them? No. So trying to set up these relationships so that later we can actually propose something. And so I'm going in with no agenda, just to sit there and see what they're thinking is important. So I'm trying to learn rapidly. It's a steep learning curve.
great.
Well, I'm not really into this field, but I would say in some, like the Mediterranean, they have this predicting the marine heat waves. They have operating system. So perhaps by introducing such, you could get all the stakeholders or the native people could be told that, yeah, we are going to do these things. And it's a possibility to prevent such, of course not prevent, but at least give warnings. But can I ask another question, because I'm not into this heritage field, but is it, when I understand that you all are looking into heritage sites and coastal interactions, do you see also look the coastal and open water interactions in this picture?
I think that loops in. If I can just round out of the last conversation, I think that was don't wait. I think that was the message that I was hearing there, is if there's an opportunity unveiled to us because of an impact of climate change, in some sense it's too late to be Johnny on the spot then. Let's have that trusted engagement, let's have the relationships built. When it comes to the question now of what about this concept of heritage values, and what is the scope or the domain of the analysis? Well, I think that is one representation of a much, much larger question. What's the domain of the analysis? Is it just aquaculture? Is it just fisheries? Or do you analyse each of those and then nest them together in a broader study beyond? Is it just one species of fish? We've had a lot of fisheries interactions pieces in here today. Or is it multiple taxa, and how do we incorporate that? And is there going to be a benefit for one and a detriment for another? That is a cascade place in there. With respect to the heritage analyses that we undertake, we look at our spatial domain, or the scope of our question is defined by the identified and recognised area of importance. So here, when we talk about Bergen, we said, well, what is it that Bergen said is the line? Now, did that mean we didn't, because the line is not at the water, it's up from the water, it's on the other side of the road here, it's the front of the buildings. Go out there and have a look, it's neat. You'll see the poles where it says World Heritage, they're in the wrong place. Well, some of them are, in terms of the location of that line there. There's a question of what's the scope? And the answer from our perspective is we start with the hard line that somebody drew on a page, and we ask the question of whether that's the limit of what we want to look at and analyse. And so here we go, it comes with that same question in there of, do you have a hard and fast, constant approach, a consistent approach, or a flexible? Is there some way of customisable approach is the word that we use in there. So is there, how do we map that in? I think it comes down to the conversation. There you go, I got 4 C's in a row there, didn't I? I like that. It's the conversation, the discussions that you have with the people who are the day-to-day managers for the property, the governance overseers for the location. It's the relationship, just like we were talking about, and developing that trust. So there isn't one answer to the question. Some World Heritage properties have designated buffer zones, and others don't. And some, like this one here, are asking the question of whether or not they should add a designated buffer zone. And all of those things change the scope, the domain of the question, in the same way as any of our analyses might change the domain of the question. Whew. So how do we define domains? What's the right domain to really analyse? I mean, we can look at the California current LME, and we can ask the question of, well, who drew the lines around the outside there, and are there any interactions that go beyond north-south, south-north, west-east, anything coming up onto land? What are the influences? And the answer is, of course. But in that case, well, then why did we just do a climate vulnerability assessment of the globe? Well, some people do, but then you lose the resolution like we heard about in the Adriatic. And we don't have the capacity to speak into that space. So I think tying in these pieces there, it comes down to defining your system, defining your objectives, and having it doable. Michelle told us that everybody rejoiced when this... the co-authors rejoiced when that assessment was completed. We won't ask how long it took. We'll just celebrate with you. But it's also a question of, could you do it again now? And have things changed already since? And so that question arises also of what's the purpose of this? Is it a once and done? I can reflect on a storyline. The Great Barrier Reef Marine Park Authority undertook a vulnerability assessment for the entire GBR ecosystem. It was published in 2007 at the end of 3 years of work. And the comment that we've heard from friends and colleagues at Gabrumpa, the Great Barrier Reef Marine Park Authority, is, yeah, it's not going to happen again. Not that anything's changed in the past 16 years since it was published. There haven't been any major bleaching events on the Great Barrier Reef, such as in 2016, 17, 2020, 22. None of those things, but that's not the point. It was a deep dive full of rigor, extreme effort over a number of years to collate all the information. And it wasn't just stakeholder fatigue, it was analysis fatigue. That I think hasn't been resolved yet. And I'm not trying to tell a story out of school, and I'm certainly not trying to put down the Management Authority for the Great Barrier Reef, because they're doing a fabulous job in a lot of difficult circumstances. And the quality of that study is fantastic. So please don't take this as me trying to pour water on what I think is a lovely fire, in no way. But it was just a big, big effort that took a big, big amount of time and a big, big amount of resourcing that you can't do again immediately. It was hard enough to seek the funding toward that. And then things shift. I don't know, apparently climate change isn't slowing down. So how do we remain agile within this? So what are your thoughts? What's the sweet spot? We have a few moments left in our discussion time, I think. Oh no, we have only a minute. Let's save that, because at the end of the day, we're going to have another discussion time, but perhaps in the discussion time at the end of the day, in addition to mapping in new inputs and content from the speakers who will be following in after the coffee break, we'll have the opportunity again to think on some of these pieces and maybe ask the question of what's the sweet spot. Before we walk out the door, please join me in thanking all of our presenters in this session, and enjoy your coffee. Was it something I said? Well, yeah, I know that. That's why I took my shoes off. Folks, thanks for coming back here to S3, where we're looking at climate vulnerability assessment by the title, but also climate impacts. And we've had that observation from within the group. Hang on, there was something, this is a broader session. Yes, we broadened it in response to the abstracts received and in partnership with the ECWO organisers. But let's get on with the more important thing, which is to receive our next talk. Olivier Tokpanou.
Yeah.
There we go, I got it. Welcome from Quebec City in Canada. Please take it away.
Hi. Hello, everyone. My name is Olivier. I'm a PhD student at Laval University, Canada. Today, I'm going to present my research project on modeling Arctic marine food webs to support sustainable and resilient traditional food system for future generation of Nunavut. This is my presentation plan. So what about Nunavik? Nunavik is located in the north of Quebec province in Canada and covers 500,000 kilometers square with 14 community which located in a coastal area. So this community depend on resource, marine resource. So this is Arctic food webs. What is the relationship between food webs and country food? Food webs makes a balance and stability of marine ecosystem thanks to the transfer of matter and energy from one trophic level to another. That make country food available to community and ensuring his food security. So that is a different trophic level. We have Arctic food webs, 5 trophic level. And this kind of country food ensure the food security of the community which depend on. So country food don't only make a nutrient role. It play also very cultural important role for this community. This paper published in 1990 showed the relationship between sea blood, sea unit blood, and diet. So for this community, sea blood is very important for physical and mental health. So that this showed the importance of country food in community life. So today, Arctic is warming more than other places in the world. Different scenarios show the increase of temperature from 2 to 4 degrees at the end of this century. So in Nunavik also, the temperature will increase at the end of this century. So this marine resource is vulnerable to climate change, but also vulnerable to commercial fishing. What is the consequence of that? This study showed the decreases in permafrost of area of 36% of land area. So that can release organic matter within Nunavik coastal ecosystem and make environmental stress. This report carried out on Nunavik for Fishery Ocean Canada showing the decreases of population of beluga in Eastern Bay between 1993 and 2015 years, and the increases of the same population in James Bay during the same period. So this means the immigration of a population of beluga from Eastern Bay to James Bay, which is under the Eastern Bay. So that means the degradation of the coastal ecosystem of Nunavik. So, following the acceleration of the impact of climate change on Nunavik marine ecosystem, this study asks questions to know if will there still be enough country food for the future generation of this community. So, we aim to establish the structure and trophic dynamic of the Eastern Bay marine ecosystem and availability of species traditionally harvested by this community. Establish the structure and function of Nunavik coastal ecosystem. Evaluate the effect of climate change, hunting, fishing on the temporal dynamic of Nunavik coastal ecosystem. There we have to make an co-construction modeling with the Nunavumit. So that means to make establish the structure of Eastern Bay food webs, trophic interaction between functional groups within the food webs and population dynamic, identify the ecological role of traditional harvest functional group. Also, we have to establish the structure of Ungava Bay food webs, identify the difference between the structure of food webs of the two coastal ecosystems, Ungava Bay and Eastern Bay, understand the role of the different functional groups of the Eastern Bay and Ungava Bay. We have also to understand the temporal dynamic of country food according to climate change, fishing, and hunting. Integrate unit knowledge, perspective, and priority. Co-develop scenario and new strategy to inform community adaptation plan. So, in our methodology, we first talk about a different model in food waste modeling. There are so many models in food waste modeling, but EcoPath EcoSim is one of the best models used in food waste modeling. This model, made by British University of Columbia, is useful for fishery management. So, this report from FAO 2007 showing EcoPath EcoSim was the best of the ecological model because, unlike the base mathematical model shows as Locta-Ventura, this model can make an trophic interaction between more than 30 functional groups. So, EcoPath EcoSim, we have to present 3 components. We have more than 3 eco-traces also. So, EcoPath is mass balance of the group of the functional group. So, this make the quantity of the biomass of every functional group at one time. EcoSim is the temporal dynamic of the different functional groups according to the environment data and human activity, social fishing effort. EcoSpace is the spatial temporal dynamic according to the location of the species and the nature of the sediment. In this study, we just use EcoPath EcoSim model. So 3 approaches will be used in this study: EcoPath EcoSim, ecological network analysis, and co-construction modeling. So these parameters will be identified in EcoPath: biomass, production, consumption, and ecotrophic efficiency. In EcoSim, we have to make population dynamic of all of functional groups according to the ice change, temperature increases, and human activities such as hunting and fishing. In co-construction modeling, we have to make participatory action research by consultation with collaboration with a community, face-to-face, reciprocal, and workshop. So this is some input parameter of EcoPath. So we have production, who is the sum of mortality. Mortality here is mortality by fishing. This can be determined by stock assessment, example, report from DFO, and some other paper who already published. We also mortality by predation, who will be determined by empirical equation for mammal, marine mammal, and fish base for fish. We also have ecotrophic efficiency, which is the efficiency by which the matter and energy pass from one trophic level to another in the food webs. It's close to 1 and 0.5 for phytoplankton bloom, 0.1 for microalgae, and 0 for predator who was not exploited. So this equation is for EcoSim equation. So it is to make a change in biomass of different functional group, who is the function of net growth efficiency, consumption, mortality, and migration. So this kind of activity will be done with the community. So we have to make workshop on climate change, marine resource, availability, and food security. So some question can be, we can discuss around some question during the workshop. So how is climate change directly or indirectly affecting country food and food security in community in the different regions? What can be done to, or what is already being done to address this impact? How could the different aspects of harvest be affected in the future? No matter what the future holds, can we use this information to better inform the implementation of strategy and initiative? Our result for this study will be similar for this result, which is Houston Bay modeling that was made by Kai Hoover in Houston Bay at 2009. So we just focus at the East Houston Bay. So we have to update Kai Hoover model, but especially the purpose of this work is for food security, not only for ecological purpose. Then we have to create another model for Ungava Bay. So in Houston Bay model made by Kai Hoover at 2009, we saw some species which have his biomass decreases according to the different scenarios, past, present, and future. So polar bear, whale, narwhal, bowhead whale, beluga, and some species have his biomass decreases. But in this world, we have also primary production such as phytoplankton who got his biomass increases according to the different scenarios. The scenario which were made in this work is ice decreases and temperature increases. So this work has been made in 2009. From 2009 to 2023 in climate change concept, so many things maybe already happened. So we have to know after this study. So to resilient traditional food system for future generation, we have to use scientific and traditional knowledge to better understand if the quantity of food available is sufficient to continue to feed Nunavumit with quality of while respecting and preserving their future. We have also to collaborate with Inuit in the instruction of ecological model which can be assessed for adaptation and indigenous people to the effect for global warming. We have also to learn from traditional knowledge to protect marine resources and fight against global warming. So this is a team member. The project has been funded by Sentinel-North. I just started. I'm now searching the data to start the first chapter. Thank you for your attention.
Thank you, Oliver. Due to time, we need to proceed, and I hope that Marina is on her way up. Thank you. If you have any questions for Oliver, we will have an opportunity to take those because we have another gap for those of you who've been in the session today. We have our last gap for the day is coming up, and so if you could hold your questions for that gap, please. Thank you very much.
Thank you.
Marina Sanz-Martín, if you would please take it away.
Good afternoon, everyone. I'm going to talk about climate velocity and how it affects the Western Mediterranean and the fisheries there. Today, at the next session, in session 10, David Skuman has been presenting how climate velocity works at global scale. Right now, climate velocity is a driver of species responses and shifts and how species are moving around how species are changing. So there are right now many people working on climate velocity, and that's one of the works I'm going to present. I have two main questions. How the fisheries trawling, the trawling fisheries in the Western Mediterranean is responding to climate velocity, and how are the patterns that we can observe, the spatial patterns, the seasonal patterns. How can we analyze that? How are them? And are these species changing in response to climate velocity? Are they avoiding climate change? Where are they going to avoid a warmer environment? Here we can see how climate velocity indicates, it is calculated as the temporal trend of sea surface temperature a long time, and divided by how sea surface temperature changes across the space. That is the thermal spatial gradient. Therefore, we obtain climate velocity in kilometers by year. For this case, I've been using sea surface temperature and applying it for each port of data I have. Therefore, we have climate velocity port specific for 50 by 50 cell. Here we can observe the patterns of climate velocity. In the south, in the middle of the Western Mediterranean part, we have the Balearic Islands, and in the south of the Balearic Islands, we have some hotspots of climate velocity, as well as in Valencia. You can see there where Valencia is, because it's a relevant area that we need to remember. And those white arrows, they kind of look like a school of hammerhead sharks, maybe. But in the Mediterranean, there are no hammerhead sharks. Those are trajectories of climate velocity. They are paths that point on an isoline on how climate change, how sea surface temperature in this case, is changing from warmer to colder areas. Therefore, we can expect that the species are following those trajectories. That's the hypothesis, because right now, it has been observed at global scale that there are many species at global scale moving polewards, but there are not many data on a small scale, at regional level, sub-regional level, and local level. So that's one of the main questions. What's happening at local scale? What's happening with in situ data? Because many studies have been using modeling data, data that are more, that has not been really more extrapolated. And let's see what's happened in the Western Mediterranean. For that study, I've been using data from trawlers, from bottom trawlers, from a temporal series from 2009 till now, in 33 ports, but our database was larger. It contained 130 ports, and here you can see all the harbors. The ones that are written are the ones that has been included, and we had a large database with 74 species, but we reduced it to 23 in order to have a quality control data. And also the landings of those vessels the pressure of the fishing fleet has been taken into account. I've been calculating two different indicators. One of them, I'm going to talk about temporal trend of landings, and the other one is the aim was to estimate seasonality of those landings. So I've calculated the shift in weeks of maximum landings from the mean of the first 3 years, of each of the first 3 years from the temporal series, and the mean of the last 3 years of the temporal series, using a limit of standard deviation of 2 weeks. Therefore, we obtain the shift in weeks, how much every species and every port has changed, as well as the shift in the coefficient of variation of landings along the temporal series. And there we go with the results. Here, we can see every region that all the ports that were before, they were grouped in 5 regions, which are the North Catalan Sea from north to south, the North Catalan Sea, the Ebro Delta, the Gulf of Alicante, which was the Valencia region I was mentioned before, Alboran Sea, and the Balearic Archipelago. Here I have used 3 species as an example. One of them is the anglerfish, the hake, and the blue whiting. And we can see 2 different patterns. One of them is a decreasing temporal trend along the time series. We see that it's a general pattern that I will explain a little bit more in the next slide, but it's quite relevant. And then we have that some species like Octopus vulgaris is delaying their maximum landings, and in the case of the blue vitic, is the maximum landings we are finding them earlier. Here we can see how almost all of the species are presenting negative trends, temporal trends on the landings, because almost all of the species are overexploited in the Western Mediterranean, except the white shrimp. That has been recently observed that it has been increasing its abundance in many regions of the Mediterranean due to rising temperatures. Here we have the 5 regions that were splitting from north to the south, and we can see that we see 2 different groups of responses. One of them is for the North Catalan Sea, Ebro Delta, and the Alboran Sea. It's one group, the most negative trends, and then for the Gulf of Catalan and the Balearic Islands are the less negative ones. The Balearic Archipelago, the less negative trends of the Balearic Archipelago is mainly explained because of the reduced tradition on fishing trawlers. There are much less fishing trawlers in the Balearic Archipelago than in the rest of the Spanish coastline. And what happened with the case of the Gulf of Alicante? We were a bit surprised about it because, yeah, it's different than the other ones. There was no reason for that, apparently. But if we look at climate velocity, and in a previous study, this region, it's a relevant region because using previous data of climate velocity and its trajectories, if we group climate velocity trajectories, they can be categorized into different types of climate velocities, different trajectories. And we can see that the Gulf of Alicante, it's a sink of trajectories, which means that we can expect that these species are coming here. In a previous study that it's in review, for the Mersal species, for a temporal series of the Mersal species sampled at the MEDITS program, using the centers of gravity, the difference between centers of gravity, which are an estimate of how the population distribution has been displaced, we observed that many species, like about 40% of the species of our database, are displacing their populations towards the southwest and towards shallower waters. The shallowing movement was mainly explained because they were trying to avoid excessive deepening, because that's the platform here is getting shallower, and they were responding to climate velocity. All the models that we were obtaining using these displacements were highly related with climate velocity, especially constrained by their thermal preferences and their depth preferences. Therefore, from this study, we assume that climate velocity is a relevant driver for demersal species, but what's happening with the trawl? What's happening with trawling data? Can we observe similar patterns for that fisheries? Here we can see that the shift of, here we come back to the previous index that I was presenting on the seasonality. And here we have the shifting weeks of landings. And we can see three main patterns. One of them is that the shifting weeks is negative, like this species here for the 5 regions that we have. And this negative shift indicates that the week of maximum landings has been delayed a long time. Here, we observe a heterogeneous pattern for the different regions. And in the last one, we see that mainly a delay in the weeks of maximum landings is found for these regions. Here we can see how the temporal trend in landings increases with climate velocity on a general scale for the whole for the Western Mediterranean, but we are really interested in how this is responding on the different regions. And we can see that the temporal trend in landings is significantly related with climate velocity for the Gulf of Alicante and the Balearic Archipelago. But we didn't find any relationship of the shift of maximum landings, neither for the coefficient of variation. The shifting weeks of maximum landings was highly related with the temporal trend of landings in interaction with the region. We can see that the Gulf of Alicante, that is here, that was the important region I've been highlighting for the whole presentation, is significantly relevant, significantly related with the temporal trends. So, to conclude, and the previous slides indicates that even though we don't have a significant relationship of climate velocity in terms of season, there's something to keep researching, as this is a work that is ongoing, and there's something else to keep working here. To sum up the conclusions of the talk, we are finding general decreasing trends of landings with the week of maximum landings has been delayed or earlier according to the species and the region. And we find that climate velocity is explaining changes in temporal landings in different regions, but particularly at the Gulf of Alicante, which is where we were expecting to receive species that were avoiding warmer temperatures. More things to keep working is that the phenology has not been clearly captured by climate velocity, but one option could be to relate it with seasonal climate velocity, that it's something that might be very helpful for that. And also, there were, using the trajectories that I've been showing you, quantifying them, there can be also a possibility of estimating and analyzing how climate connectivity is affecting the fisheries in the Western Mediterranean. Thank you very much.
Thanks, Marina. We have the opportunity for some questions and also any questions for Oliver to respond to from the previous talk as well, now that we have an opportunity for some time. Are there any questions?
Hello, thank you for the talk. I didn't really understand why the species were shifting southeast. Well, if you can maybe explain a bit more.
Yes, species in the, we thought that, we saw in the models that it was a response to climate velocity, and also in terms of their thermal preferences and their depth preferences. That's an aside work, but I think it was relevant for these results to present it. And other option, we were also considering to add more layers or to add more data, like marine heat waves, like using climate velocity as a driver, but we can add more things to explain it. but mainly we can conclude that they were tracking climate velocity in order to avoid this region. That's what we were seeing, and that the responses were constrained by their thermal preferences and their depth preferences. I can talk more about that later, because I have this part of the work is already done and it's already in review. So I'll be happy to talk about it later.
Okay, thank you.
I have a question. The climate velocity calculations, so the spatial gradients and the trends, were undertaken using sea surface data. Is that correct?
Yeah, it's based on. I mean, it can be a multi-approach, a multivariate approach can be used and has been done. That other studies has used precipitation or maximum or minimum temperatures, for instance. So it can be combined. It can be based on different variables and a combination of variables. In this case, I've been using only sea surface temperature, but for future works, it could be great to look into depth, because it has been observed at global scale that climate velocity is changing in depth, and a recent study has presented that in deeper layers, climate velocity is increasing. It's increasing even higher than compared with the sea surface.
Oh, great. The end of my question was going to be, have you looked at depth? So I'm going to ignore the rest of my question because you've already answered it. Thank you.
This is a question for Oliver. Thank you for your presentation. I was just wondering, how, in the work that you're doing with your colleagues, the discussions with the community members regarding perhaps their perceptions of change and what the future might hold for them in terms of food and nutrition security. And I like the paper that you shared in the beginning about, you know, food and cultural identity, et cetera. But if what is defining their cultural identity, if those species are under threat, do the communities also feel a connected threat? And if so, in what way, and what might they be looking at for future options to ensure food and nutrition security that might actually have a negative impact on their cultural identity and how that's related to what they eat or what they might not be able to eat in the future? I'm not sure if I'm making sense with my question, but anyways.
If I understand your question, I'm sorry. What we hope in the future, according to the food security and country food relationship between country food and culture, right? Okay, thank you. Today, why I chose this kind of for work. I'm being interested because I come from West Africa. But when I was doing my master degree, I remarked that local people have more knowledge according to the natural thing, like sea species. So after finishing my master degree, I discovered this research online. I applied, but I had a chance to be took. So I already got something like that in the past. Local people today, we have to take her in account in our climate change research, because there is a real observation. It makes a real observation according to the climate change more than us scientific people is in our lab. So, according to the regarding the relationship between country food, culture, and culture, today in Nunavik, according to regarding to Hoover work, we remark the decrease of so many species. So, if this continues with this frequency, maybe in the future, we don't know, some species can decrease. A new species can come to colonize the area. So that this time, what indigenous people can do to adapt for the new situation? Can, for example, choose to eat a new species who colonize the area, or leave the area? So this kind of question, we have to get a solution by discussing with them in the workshop and so on and so on. So I think this will help us to have a solution to save country insecure first, food security, and make have a solution to adapt for the new situation of effect of climate change. I don't know if I explain very well I give a very well answer for your question.
Thank you very much.
Okay, thank you.
Thank you. So folks, as I had mentioned, we had another cancelled talk for this next, for the current time period. I'm hoping that I'm getting a nod from the tech guys. Do I have the right slot? I haven't gone backwards and gone wrong here. And the time now is 4:08, so we have another 7 minutes. So at this current time slot, we had a cancelled talk. One thing that I wanted to do at this point was to note two things. One, there is a special issue which is a subset. It's focused on a subset of the discussions that we have been having in this session on climate vulnerability assessments. And some of those have been on natural systems, some of those have been on heritage or values systems there. So one of the questions we have for discussion that we'll be thinking about after, in the last 15 minutes of our session today is, what are the things that species-specific or species-related assessments might be able to inform heritage values assessments with, and vice versa? What are the learnings that could come from heritage values assessments towards biological based assessments? All of those are covered within this space. And the impacts, the climate impacts we've spoken of, and some of those have been presented here, have been in one frame or the other, the biological systems or impacts on heritage systems. And then how do we learn about the factors that are generic to both of these? Communication, the understanding, the development there, the responses. What are the actions that can be taken there? Are there things we can share between these two connected but distinct areas? And of course, there's ones that are in between. This is not a discrete set, it is a spectrum. But if I focus on that, the cultural and natural heritage concept on one side there, so this is the connections that we have to some kind of values definition. And we've already discussed the purpose there of, well, is that a cultural entity in and of itself if we're ascribing value rather than just looking at a quantitative analysis of abundance, presence, etc. There is a special issue on assessing impacts of climate change on cultural and natural heritage in the journal Heritage, who have provided a sponsorship for one of the speakers presented today, but also have provided an award. So nobody knew this when they signed up and submitted to S3 because it didn't exist at that time. Nobody knew it, whether they were coming from a perspective of a values-based assessment or a biological-based assessment of climate vulnerability, or whether they were describing climate impacts, sensitivity thresholds, etc. Nobody knew this. It didn't exist at the time. But there is a special issue in the journal Heritage, and there's information here. It's also available on the website. If you go Heritage Journal Special Issues, it's the very, very last one on the list, because the deadline is 31 December, which we all know really means 15 December, because nobody does anything in the last 2 weeks of the year. But then we also know that special issues often, not always, get extended. So perhaps it doesn't mean the 15th of December, but maybe it means the 15th of, just pick a different month. And you're probably right. So if you have interest in that, then please let me know. And for those presenters who have been sharing, please note that there is a potential award that you're in consideration for at this point in time. And if you haven't presented yet, there'll be an opportunity to do that tomorrow. But, except for Kirsten, she doesn't get an opportunity to present tomorrow. She gets an opportunity to present today. So bearing in mind that we have just through some additional question time, which was fantastic, and then a little bit of advertising for a special issue, I'm going to leave these up here. I'm not going to hand them out. I'm not going to watch to see who's taking them. But please, by all means, if that is of interest to you, cultural and natural heritage, I want to emphasise within that there. Our next presentation is a pre-recorded online video, and after which we'll be having a discussion time to culminate today's session 3. So I do invite you for the next 30 minutes to firstly be enthralled by a pre-recorded presentation and then to be ready for a time of discussion. Thank you very much.
Good morning, everyone, and welcome to our presentation on our research titled Understanding Patterns of Hard Coral Demographics on Kenyan Reefs to Inform Restoration. I am Swaleh Aboud, and co-author under this study are Michelle Gudka and David Obura. And this is the outline of this presentation, starting with the background to research question and lastly to acknowledgement. On the background of this study, firstly, it is well documented that globally, many reefs are declining due to either natural or anthropogenic stress. Also, based on the recent publication by Obura et al., shows that Kenyan reefs are at high risk of collapse, mainly due to overfishing and climate change. Therefore, this makes important now to understand the recovery potential of these reefs, and one of the factors is to consider or to study the successful recruitments, which is very important for coral reef recovery and resilience. It is therefore, under this study, we look at coral recruitment patterns in the Kenyan reefs, and then we relate this pattern to the adult community to see if there is continuous growth from recruitment to adulthood, or there's a point where there's a break that stress or threaten the growth of recruitment to adult. This study, it falls under the broader scope of Cordio's National Coral Reef Assessment, which is currently being carried out, and therefore both the fieldwork and analysis for this study is still ongoing. Our research questions based on this preliminary analysis is that, first, what is the distribution pattern of coral recruits on Kenyan reefs? Second, we are trying to look, is there a relationship between recruits and adult coral communities? And lastly, we are trying to see if there is survival chances or survival potential of recruits reaching to adulthood. We collected this coral reef data between 2020 and 2022, and on each year we conducted the survey during the northeast monsoon season, which is a good season with a calm ocean and also good visibility. And so far, we have covered 25 locations with 46 sites. And these sites were selected based on either they are part of the global coral reef monitoring sites, which have been previously surveyed. Also, we were able to do an exploration to identify the new sites, which we have identified and also conducted this study. On our method, we use the underwater visual sensors technique, whereby a diver swims along the predetermined path and counting and tallying any observation required. So for the adult corals, which we consider to be the corals with colony size larger than 10 centimeter in diameter, and we focus only on the 23 pre-selected genera. These 23 genera were selected because they are extensively distributed and common across the Western Indian Ocean region and consist of genera with a gradient of responses to heat stress that is from sensitive to resistant and with diverse functional traits. Hence, the diver, as he swims or she swims along the 25 by 1 meter transect, he measure and recording any observed of the 23 genera. On the other hand, for coral recruits, which we consider to be the coral with colony size less than 10 centimeter in diameter, were counted in a 1 by 1 meter quadrat, and each quadrat was placed at an interval of 5 meter along the 25 meter transect. This means at each transect 6 quadrats were recorded. And on each site we surveyed 2 stations. With each station we laid 2 transects, meaning one site had about 4 transects. The data was processed and analyzed using the free software called R. Our results on the distribution patterns shows that there was a significant difference in terms of recruit densities across different locations surveyed under this research. And we see that Kisite Marine Park and Marine Reserve had the higher density, while Likoni had very low density. So we also tried to explore further to see what has caused these differences. And we started by looking at the pattern across the region, that is from south to north. Unfortunately, nothing came out clear here because the Kisite Marine Park and Reserve are on the north, while Likoni is also on the north. So there's no clear pattern in terms of region. Therefore, we explored further to my next slide, which we see if there's any patterns based on the reef type or the management type. Unfortunately, also on the reef type, the means were almost similar, and there was no any significant difference between the inner reef and the outer reef. The inner reef, we consider the reef that faces the land, while the outer reef, we consider the reef that are facing the ocean. Also, on the management types, between the 3 management types we identified, which is the no-take zones, which are area where fishing is prohibited and is not allowed, and the partially restricted area. These are example of marine reserve in Kenya, where fishing is restricted based on either the gear type or the fishing method, and the open access, which are area with which is open for fishing. However, on the same, we see from the graph that there was no significant difference, and the mean are almost similar. Our results on the distribution patterns of the coral colonies by their sizes shows that for the recruits, just to remind that recruits we considered to be the colony less than 10 centimeter in diameter, we see in terms of their density, they were increasing in their numbers from the lowest to the largest size class, while on the same density patterns for the adult colonies, which we consider to be the colonies larger than 10 centimeter in diameter, we see that there's a decreasing pattern of their density as the size class is increasing. However, in terms of the area for the recruit, we also saw the same pattern. The area was increasing as the density of the recruit is increasing. However, for the adult, we see from the density where there's a dropping in terms of density as the size of the colony is increases. There is a decrease in their numbers, but for the area there was an increase of the area as the size of the recruit is increasing. So generally, we can say that in terms of the numbers, the sizes, the density is decreasing with the increasing in size, while for the area cover by the coral is increasing. Is increasing when the size of the colony increases. So we are still exploring further on this to understand the pattern, either by location or by including other factors. But for considering the area under this, we can see that there is a continuous coverage in terms of area from the smaller size from the smaller size, which are recruits surviving into adults, which is a good sign. Exploring further in terms of the coral community to see the community between the adults and the recruits, how are they correlating? And the correlation shows to be very high at almost 77%, and most of the genus or the genera are falling within the high correlation path of a high correlation path between the recruits and adults. However, there are some of the genus which was slightly differ. For example, we have Platygyra and Favia, which had higher adults than recruits, which imply that adults are surviving. But if they do die, not a lot of recruits rebuild to the population. At the same time, when you look at Pavona, which had higher recruits than adult population, which seems like the recruits are not surviving into adulthood. Also, we explore further in terms of differences in terms of the heat tolerant or the thermal resilience genera. These genera were based on the study by McClure, where he categorized the sensitive corals as the coral which are susceptible to bleaching from marine heat waves, which include the genus of Acropora, Goniopora, Lobophilia, Montipora, Postulopora, Porites branching, and Stylophora, while the resistant corals, which are heat-tolerant corals, include the genus of Porites massive, Pavona, Cusinaria, Galaxia, and Hyenophora. So from the graph, we see that most of the area are dominated by resistant coral, which is a good indication, but not only a good indication, but needs to try to see the relationship with other factors. For example, if you see Mariraini here, which is mainly covered by, which is completely covered by resistant coral, but this site also from the benthic data show that this area is mainly dominated by microalgae. That's why we need to explore further to understand the levels of other factors which influence or which impacted the coral recruitment, like overfishing, like herbivores or microalgae, to understand the pattern well. And also the sites like Kisite Marine Park, which is dominated by the resilience, by the sensitive coral, may indicate also that this site, the survival, may be affected if there will be an increase in ocean warming. Our conclusion based on this preliminary analysis shows that there's significant difference in recruit distribution along different locations, and that most of the recruits do survive to adulthood, and there is a consistent of a coral community between the recruits and data and adult corals. Also, the dominance of resistant coral, which indicate a good sign, but also may indicate that there's mortality of sensitive coral, while the dominance of sensitive coral may be affected in the events of change in ocean temperature. Moving forward, we'll adding more data from the survey that will be undertaken next season, and also analyzing and exploring further to understand the current recruit level in comparison to the historical level, also to link our recruit data to the connectivity data to get stronger recommendation on the sink and source reef, also to understand which site can have a capability of self-recruitment and which need human restoration, and lastly also to include the other factors such as microalgae and herbivores. We would like to acknowledge different institutions and organizations who contributed in one or another to this research, specifically to the NORAD for funding this research under the National Coral Reef Assessment. Thank you all for listening, and I'll be happy to get comments, feedback, and questions. Thank you.
So as that was a pre-recorded session, please do submit any questions or comments you may have via the Hoover app, or please be in contact directly with our presenter. Whew, 15 minutes to go. I know I promised a discussion time. Before I do that, I just want to poll the room. Are people up for a discussion? Because if we're not actually up for it, then maybe we shouldn't try to press it. So I'm handing a free pass in case people just say, it's beer o'clock, I just want to go and look at 2 posters and use up my drink tickets. Actually, we can't use them until 6 o'clock, right? So get in early, look at the posters so you can dedicate your time to the drinking. Yes, no. Go in and whatever way around. You haven't walked out. And because you haven't walked out, I'm going to take that as a sign that there is an interest in discussion. So I just want to mention that. And still nobody is walking out, so this is great. I'm excited. A couple of the notes that do you want to run this or do I want to run this? Tag team. Okay, we'll tag team. A couple of the notes that we wanted to bring up, well, the first of these is the question of transparency. Transparency in a climate vulnerability analysis or assessment. Is it important, and how can we be transparent in what we're doing? Are there any examples of how people have demonstrated transparency in their approach that they've taken, or do you just have an idea in terms of the concept of transparency? Thanks, Matt.
I think one of the approaches that we took when we were doing the initial scoping for our assessment, whenever we would talk with a stakeholder, we would let them know who else we're engaging, and one of the questions we would ask is, who's missing on this list? And so it was a way that we could grow the stakeholder group, and it was a way for stakeholders to identify their peers and their partners and bring more groups into the mix to have their views be heard.
Were there ever any issues of conflict? Party A would not work together with Party B?
There's always the risk of that, yeah. I can't remember any specific instances that we encountered, but a lot of it was understanding the needs that those stakeholders have. And since it was a scoping exercise rather than the actual implementation, they were happy that we were asking them those types of questions rather than telling them afterward what we had done.
Thank you. I've certainly had in a vulnerability associated workshop, but not an assessment process, had to do people management of put one person on that side of the room and the other person on that side of the room, which in some would argue is contrary. You don't want to put all of your people of one type in one space and all of the opponents or proponents or whatever. Separating, divide and conquer doesn't win in that that scenario. But sometimes individuals or personalities, you can put them at opposite ends of the field and hope they don't meet in the middle. I think one of the key elements of transparency is communication. I think if you are walking into a space without a clear method on how you're going to communicate and to whom you're going to communicate, and one of the things that we reflected on in the workshop on Sunday, there was one description, I think it was from Jacob. He said we actually had 4 different audiences, and we had to think about how would we communicate to each of our 4 audiences. And one of those is the resources, the funders, the donors, whatever you like to call them, and one of those was the general public. And I don't know why I put them at opposite ends of the spectrum, because sometimes the general public are the donors. Certainly your stakeholders, your rights holders are contributing their time, their effort, their energies. And so donor can have a lot of different definitions, not just a monetary value in there. Any other thoughts? Thanks, Anne.
Actually, not so much of a thought as a question. Maybe you or someone else could elaborate on when you do have those 4 or 5 or 6 different audiences, you're trying to be as inclusive as possible, and you need to be very sensitive to the different types of language or how you communicate the information, or to also, encourage any kind of feedback or contributions of opinions from people. How do you or others, it can be very challenging when you've got the different groups, but you want to be able to reach everyone and be as inclusive as possible. Anyone to share on that?
Thank you. So I just want to add to that question. I don't have the answer for that. But I think something very important when you're working with these kind of workshops is to try to handle the power relations and the power dynamics are within the group. Because even though we try to be as inclusive as we want, there are some relationships or some elephants in the room that are not being spoken about. And then some people, some stakeholders or actors are not speaking up or not talking because of these kind of dynamics. So if someone had experience in that and how to manage this, because we had the experience in a workshop where, the institutions just took over the workshop and it was quite difficult to manage it, so yeah.
So what sort of strategies do we have in response to such an idea there? If there is a perceived power imbalance within a connection group, however we define that. Any thoughts, any ideas? And let's not forget about the other part of the question as well.
Yes, I think in terms of participatory approaches, you can mix a little bit the techniques and the space and time you are mobilizing the stakeholders you're talking with. So when there is a strong power asymmetry, You can have some talk in plenary session, but it's not good at all when you have a strong power asymmetry. So it's good to mix your session with some word cafe, for example, where you have little tables of stakeholders, which are basically heterogeneous focus groups. And afterwards, you can have another group doing a complementary, adding some elements with a complementary manner. And usually it works really well, and just you can facilitate the debate. And doing this, usually it works really well with power asymmetry. And if you see quickly a power asymmetry, you can, there are techniques also to deactivate this power asymmetry in just temporarily. Sometimes just giving more power, but it's complicated also to estimate where there is more equitativity and not. Yeah.
If I can, sorry.
I think Scott's running out of steam. He's been talking all day.
I have a comment though. So, I think that one of the reflections there is that, like we've heard in the, yeah, I am running out of steam, but that's okay. One of the comments that we've heard in the workshop is that we need to cut the cloth of our vulnerability assessment to the system that we're assessing. And I think this fits in here as well. We need to approach the assessment and the way we acquire the information that is informed by the people who are there. So we might need a plenary session, we might need breakout groups, we might need a survey tool, we might need to dig up a nice Google form so that people can have the opportunity to individually respond anonymously. And so, I mean, what do you say, de-identified. Not anonymously, but de-identified. Anonymous data is hard, but if you can de-identify it before sharing it, then that's a good thing in there. I think that same perspective fits with the answer to the communications part. When you say, who is my target audience? Do you report back, Matt, have you reported back to everyone using the same approach? So what approaches have you used to report back to what types of different groups?
For some of the groups, you have to talk individually. It needs to be one-on-one communication, either setting up a phone call or a time to meet in person. Other groups are just happy to get an email and a quick update. Hey, this is what happened, 2 bullet points, we're moving on to the next step. But others needed to know in depth what happened during that last phase, how they were involved, how they can be involved going forward. So it runs the spectrum of everything from group interactions to individual interactions to quick notes.
I think it's really interesting just on the perspective of reporting back out of a project. Your donor, your funder likes to see the big, glossy, fat report. Your policymaker wants to have the 3 things that they can do with it on a single page, because they don't have time to read that single page, let alone the fat report. And your person on the street doesn't want to read either of those things. They want to see an infographic and they want to hear you tell a story. So I think in the same way that we speak about these notions, it's a cut your cloth to fit, a horses for courses. Anybody got another metaphor that we can throw in there?
I was just wondering to what you just mentioned about the diversity of the ways that you can communicate it back. To what extent is it worth it to speak with the stakeholders beforehand, like how they would like to have the information being provided, or do you do it like in a more intuitive way? So we feel like they want it this way or this way. That was a question.
I think there was a question mark at the end of it. I'm pretty sure there was. I like it. Would anyone like to respond to that? Thanks, Oliver.
Okay, thank you very much. After infographic and told story for in a transpassary in information, we also can put video and making this video what we want to, the information we want to explain for people. So after watching video and discuss every in group first, every people give his conception about the information, and then people can discuss in group. But me, and I'm the moderator. I can assist every people according to the work, the question, and also assist every group. And finally, we can make the summary of all information who is in the video. I don't know how to. I'm sorry for my English. I hope you understand what I'm talking about.
You could just say it in French.
Okay. Can I?
I think you can.
Okay. I don't know if somebody understands French here.
We'll find that out next.
Ok. Ok. Merci beaucoup pour. Il est question de savoir comment faire la transparence dans un workshop, n'est-ce pas? So, dans ce cas, nous avons différentes méthodes. Nous avons la méthode, donc, le frère parler, il faut parler d'une histoire, partie d'une histoire, et aussi infographique, dont l'autre frère a parlé là-bas. Et je disais tantôt que, à part ces deux méthodes, nous avons aussi la méthode de vidéo. Et on peut former une vidéo. Aujourd'hui, avec l'intelligence artificielle, on peut créer des vidéos, des dessins animés dans lesquels on peut intégrer toute l'information qu'on veut expliquer. Par exemple, sur le changement climatique, on peut mettre l'océan avec les activités humaines qui produisent des effets de gaz à effet de serre et autres, et faire cette vidéo-là et donner une tâche individuelle à chacun des membres, et aussi organiser des tâches en groupe, et procéder par les APC, approche par compétences, pour assister individuellement et collectivement les groupes, et enfin en plénière, ce que cache la vidéo, l'information qu'on veut véhiculer ensemble, on peut faire la plénière là-dessus. Je vous remercie.
Well, you had your hand up next, but is there anything that you'd like to distill?
Yeah.
What Olivier said to all of us.
Yeah, actually, I'm lucky because I understand French. But it was very interesting in English and in French. Yeah, it's good. But I think you're right about the video. You have also to diversify the media, because some stakeholders prefer other media, other time, other space to communicate. But also there are two major time space, I used to say, that are essential in stakeholder engagement. It's prior to your main research question, and afterwards the outreach part. So these are the parts which are essentially avoided or underestimated by lots of researchers, but they are essential if you want to mobilize stakeholders to bring them to transformative change, to accompany, to be with them with this. So prior, you have to assess what are the motivations, the power relationships, the organization, the functioning of the social ecological system before having your research question asked and answered, because if not, you will be with a big bias, and many times it happens even in stakeholder engagement where people are more aware of the diversity of opinions, of values, but still we have to work on this. And the video is very good afterwards also with the outreach.
Really? Shall we? Yeah, okay.
The purpose of workshop is begin to different idea and finally have a same mind, a same. So first we also have to know the perception of everybody according to the information we want to transmit. So finally, people at the beginning know his perception according to information. And finally, he will agree or make a correction of his wrong perception before. I don't know if you understand me. Beginning, somebody can have a wrong perception. Some of them can have a good perception. But our purpose is finally everybody have a good perception. So it's very important to have the perception for everybody before beginning. So I ask question, a big grass, we call it big grass. I ask question, what do you think about it? What do you think? What do you think? We collect it, we make our method. Finally, if before, I don't know, for example, climate change destroy the sea biodiversity. Finally, that is, so thank you very much.
I think one of the key outcomes that we had from our workshop on Sunday, and we heard this from various voices, various practitioners of climate vulnerability assessments, is the notion of co-design, co-develop, co-produce. And we even heard that today, earlier, those words, we heard some of those precise words again today, independent of what we discussed on Sunday. And I think that's what we're hearing and what we're discussing here. Getting everyone on the same page with what's the vision, the purpose, and how we're going to get there. Really important. And in the same way we can reflect on that with our communication is a part of that. You start from the outset and you say, this is what we're going to do and how we're going to work together to work out how we're going to work together. And then we're going to continue that through. One of the other key moments that I heard out of today, which fits into all of this, and it's really important, we're talking about how do we communicate to various peoples. I think back to Jenny Shaw's talk where the knowledge return happened to the Indigenous peoples in that work there, the Mbogelah mob at Garagru, and that element of mutual understanding and respect isn't limited to Indigenous peoples and working together with Indigenous peoples only. It works for all local communities, the people who are investing in. If you're not giving back, then we can exacerbate or accelerate the ideas around stakeholder fatigue, which we also discussed today. We've had a good journey through this workshop talking about values and the vulnerabilities, about natural systems and their vulnerabilities, or components of natural systems and their vulnerabilities. We've heard about cultural heritage connections, natural heritage connections. We've had descriptions of climate change impacts, or even in our last talk, preparations and understandings towards now taking a next step to say, well, hang on, we have this notion of susceptible, resilient coral recruits. What's that going to mean for the next? This section has embraced and covered over all of those different aspects of climate and impact, vulnerability, assessment on different systems. I would like to offer my thanks to all of the presenters through the course of today, to you for holding out, staying till this last session now, and for all of the discussion moments that we've had through the course of this. It's been really great. But we ain't done yet, because don't forget there's a series of S3 posters that are positioned. They're inside one of the rooms, not just in the corridor, out here. And tomorrow, after the plenaries, before and after lunch, we have the culmination of our oral presentations. So please, come back. We've got you're only halfway on the travel. You're in the layover lounge, and we're going to get back on the plane, fasten seat belts, put up the tray tables, and get back in it tomorrow after the plenary sessions. So we look forward to seeing you tomorrow. Have a great evening, and yeah, don't forget the posters. Thanks, everyone.